If you're here, I am just getting things set up, so bear with me for one moment. I gotta change my cable. I'll fix the music in a minute. Just a minute. Alright, let's see if we can get this chat working. I gotta get used to this streaming stuff. Let's see here. Let's pull this over here real quick. And I'll just bring me over here for right now. Let's see here. Let's refresh this. Alright, so we got the radio going. We got the programming stream going. Looks good. Let's see this chat. Oh, let me pause that. Alright. Nobody in the chat yet. Let's make sure we can get our... Hey everyone. Setting up. There. Setting up now. I'll just stick to that. And maybe we'll put this like kind of over here. No, let's do it like that. We'll put it on there. And we'll stretch that out to like there, roughly. Alright, and let's see, we mute that, put it to live. Alright, that's interesting. Alright. So there's the chat there. Do we have... How do we activate this chat on screen? That is the question. And how do I get my music to play through my headphones? I would really appreciate... It says my headphones are connected, but... Alright, let's turn this speaker off. How about that?
Power off.
If we turn that speaker off, can I get the music into my headphones? I did see it. It is connected. It says it is connected. Alright. So if it's connected, then where is the audio? If we click on that. Bluetooth. Boltune. Devices. Create a new device. Boltune. It says connected mic. Alright, let's disconnect. And reconnect. Alright, there we go. So loud. So freaking loud. Why is this so loud? Ridiculously loud. Alright, we got the desk. Oh my god, how do I turn this down? Sorry if you're there. I didn't realize this is fucking blasting my eardrums. Hold on. Alright, why don't we just control audio via OBS. Yes, please, God. Oh, thank God. Oh my God, that's so loud. So let me put, if I go to here, I should be able to hear it now. Monitor and output, yes. Or you know what, I'll just listen to the stream. Monitor off. Alright, now let's go back to the stream and let's see here, turn that volume on. Okay, it's still really loud. How's that? Oh, much better. Okay. Whew, if you guys were here a minute ago, that was so loud. My bad. Totally my bad. Okay, Mad Spin. Sounds good right now. Alright, sounds good. Alright, music a little louder or no? How about that? It's gonna be a dark stream. I can't program with all the music is a lot lower compared to your voice, yeah. Alright, I'm gonna turn it up a little bit more. Let me know what you think. Frederic, what's up? How's it going? The music is barely audible right now and your lighting looks fine. Your face with a lot darker. For your face with a darker. Yeah, that's what I figured. It's I can't sit here and stare at the screen and program for hours with all the blinding light in my face. So Frederic says the music's too loud. Okay, I'll turn it down a little. Hold on. Yeah, I think the music's a little too distracting. How's that? Get this out of the way so I can see better. Actually, I'm going to put it on this side over here. All right, where did my, okay, where did my, FS Chill Radio, it's right there. Okay. Let me just, make sure I don't see it. She gone. Interacting. All right, let me turn it off, turn it back on. Drumless tracks, yeah, okay. Yeah, this is, so the music, the loop I have going over there, the FlowState Chill Radio is, okay, hold on. I cannot control my audio in my earbuds. This is annoying, hold on. OBS likes to take control of my headphones and then it doesn't want to let go and it's really annoying. But what I was saying was the loop that I have going is this like 24/7 music stream that I'm starting, and it's just real basic right now. I just picked out some tracks and threw it together just so we'd have something to listen to on this stream, but I'm gonna be updating it very soon. Okay, how do I get, sorry, hold on one second guys, I just gotta figure out how to get my earbuds to, I just have to get my earbuds to cooperate, and I need this to cooperate. This would be nice. Shut down source when not visible. Refresh. Yes. Okay, refresh cache. Alright. There we go. Finally. Okay. Let me interact with that. No thanks. We will come on down to here. That's how we want it. Right there. Okay. Now, I would like to be able to get the music in my ear, but I don't think it's going to happen because OBS has taken control of my earbuds, and I don't really want to troubleshoot that right now. I would rather just get going, I think. Docs, audio. How do we see the audio tools? Edit. Advanced audio properties. Yeah, I already got that. Monitors turned off. So, let me just check. Sorry, I'm not trying to make weird mouth noises into the mic. Gotta be more mindful of my... Alright, you know what? We're just gonna go with it. I'm gonna put the earbud down and we'll just get it going, because I'll have to figure that out another time. It's not that important. It is not that important right now. Okay, so let's figure out the chat. I set up some chat things here. So obviously we got some people in the chat, and I have this little thing off to the side that should be showing the chat, but I need to figure out how to make it do that. I'm pretty sure I can show this on stream, right? There's nothing important here. What if I try, let's try the YouTube. Oh, this is not, okay, this is a, let me try here. This is the right, yeah, this is the right chat. Why is it not showing up? That's the question. The chat. We need the chat. Control. Let's try and refresh that cache right there. Do we have a chat? Video is a little delayed from the audio. Uh-oh. How much of a delay? Like a second or 2 seconds, or let's see, this says, where's the chat? Okay, seems like less than, okay, so we can see the chat on stream now. Awesome, that's so cool, man. Seems like less than a second or around a second. Okay, yeah, we'll see if it, are you able to check the stream on your end? I have it open in a browser window so I can listen to it, and then I also have like the stream health control panel thing open as well. Let's see here. Let me check the stream health underneath the studio. Studio analytics. Okay, if I go to content and then if I go to live, then I can click on this and it should be a good connection. I have we just got fiber. I just got AT&T fiber. They just installed it in my area, so as soon as they had it ready, I had like a notification because I wanted to get off of Cox. Here in Pensacola we have Cox, which is like basically the same thing as Comcast. It's terrible. But as soon as AT&T got the if it looks good on your end, then it might just be me. Yeah, I mean, it's hard for me to tell really unless I let me get my earbud back in real quick and I'll just do a little check. See what it sounds like to me. That's cool, we got the chat going. That's awesome. I got Comcast. I want to switch to FiOS. Yeah, I've heard of FiOS, but I can't. It's been a while. I can't remember off the top of my head. Let's see here. Where's my audio playing? Is FiOS, FiOS, is that Verizon? Boltune, yes, give me the Boltune. Boltune headset, please. Okay. Oh, that's so much better. Yeah, FiOS is fiber from Verizon, yep. Okay, so sounds pretty good. How's the beeping on the chat? Is that fine? Is it too loud of a beep? Baka Blitz, what's up? You've joined to, I'm not really sure what you've joined to, but my camera looks like it's glitching out. All right, I think we're good on the chat. The chat looks like it's showing up just fine. I just want to make sure we're all stable. Beep sounds okay, not too loud. Okay, cool. I have it turned down on the like lowest beep setting. Yeah, my camera is a little glitchy. I don't know why. It's lagging. I wonder if I switch to, well, I mean, I guess the camera is not that important, really. We're not really here to look at my face. First of all, let's put that up there, and let's do a little experiment, if you guys don't mind. Oh, okay, hold on. Maybe I need to keep that app open, because I don't see... Alright, fine, I'll keep it open. Here we go. Yes, allow. I didn't realize for the Social Stream Ninja, you have to keep the app open. Okay. And so let's do that. Because I want to make sure all of the chats are coming in. I see one more from Madspin there. And let's see what happens if we do that. Refresh the cache. All right. Hit that. Testing. Okay, I see mine coming in. Okay, we just missed one, but I think it's just because I had the app closed. I'll leave it open. We'll just minimize it. All right, let's do a little... Can I do an experiment with you guys? Is this fine? Nice. Cool. Thanks, Baka. All right, so I want to try, just really quickly before we get started, there's a couple of things I wanted to see. We have this poll thing here. And, oh, no, that's the one. I think with the poll, it should be that, if you type in, well, actually, I guess I can try it. Let's try hashtag Buffalo. I think it's supposed to be like a little pound sign hashtag kind of thing. Chat. Graphical poll. That's the, is that the graphical poll? Yeah, it should be. Allow multiple votes. It says a hashtag word to vote. Chat poll. If you guys want to try a some kind of hashtag word, see if that'll show up. Wonder if I hit reset poll, maybe. End poll. Okay, so theoretically we have 2 votes. We have buffalo and we have test. I don't know about that flavor of wings, but let's try to end the poll. Okay, now it's closed. And I don't know where the results are supposed to show up. All right, whatever. I'll figure this out later. Let's get going. All right, so we have, first of all, we're going to need a text editor. And I guess we're going to need Comfy, huh? Comfy is right here. Sorry, I'm trying to watch my little mouth sounds. Okay, here we go. Let's do it. All right, here we are. I was just messing around with this little, trying to make a little basic loop. You know the I don't know if you guys have probably heard. I've been doing all right, man. How are you doing? Baka, or I don't know. I shouldn't say man. I kind of assume, but looking in the analytics, it tells me that like all of my viewers are like men aged 25 to 55. I think like 35 to 55, somewhere around in there. I was surprised that I was getting viewers in the like upper age range, around like 55 years old. But I guess it makes sense. My camera is bugging. All right, cool. Yeah. Every time I say man, then I'm like, oh, wait, maybe, I guess. All right, there goes. My camera looks like it's much better now. Okay, so this is what we got on SVD. I'm going to make myself a little smaller. Yeah, I have the like Logitech software for the mic, the little G Hub thing right here. And yeah, I can set like a gate and a compressor and all that. But I need to get back in there and mess with it. I haven't messed with it for a while. But yeah, I need a screen for the P sounds and the T sounds, so it's not too like, what do they call them? Plosives. The plosives. The quality sounds good. All right, cool. As long as it sounds all right for now. right, that's cool. We got our little equalizer. We got our ticker down there. Oh, our ticker's not even going. What's going on with the ticker? Why is the ticker not going? Let me just make sure that's going. Refresh my ticker. Okay, maybe it's in here. Maybe it needs to be set right here. Let me just double check. Ticker source, ticker. There he goes. Okay. All right, we got our ticker, we got our EQ, we got our chat. We have the radio, although I don't hear the radio. Can you guys hear the music, or do you want to hear the music? Yeah, we got everything going there. The last thing is... Okay, I can hear it a little bit. I don't hear anything right now. I can hear it a little bit now. For some reason it looks like it's really loud. I can hear it now. Okay. Yeah, okay, cool. Alright. It shows like it's really loud on my meter, but I guess it's not that loud. Alright, yeah, I'm gonna try it like right there. Alright. Is that too loud? YouTube is not receiving enough video to maintain smooth stream. I got fiber internet, bro. It should be a gig up. Analytics. Stream health. Incoming signal is probably loud, but you're setting the volume to be low on output. So it's fine. The music level is good compared to my voice. It's not too distracting. Yeah, it's not too bad. About the same level as your voice. Alright, cool. I'm gonna turn it down just a little, and we'll go with that. Is the stream like glitching out or lagging or anything? It says it's under the stream health, it says it's not receiving enough data to maintain smooth streaming. But, I mean, as long as you guys can see everything, then I guess we're good. It might just be something on YouTube's end. I mean, it should be... Fiber is... music is very too loud. Okay, yeah. It seems like it was, like, quiet, and then it just all of a sudden got louder. I'm gonna turn it back down. Yeah, that's what I was thinking, like 20% or so. Because you just wanted to be in the background. Right, yeah, exactly. Alright. Yeah, that sounds a lot better. How's that sound to you guys? Frederic, too loud? Are we good? No lag for me, things are smooth. Okay, cool. Yeah, I think it's just something on YouTube's end, because fiber is what do they call it? It's the same up and down speed. Like most internet is, you know, you get like a gig down, but then it's only like 100 megs up, but fiber is full duplex, that's what they call it. So it should be a gig down and a gig up. So I would think the stream, like the bitrate, should be fine. It says it's like not receiving enough data. It's so weird. All right, so if everything sounds good for you guys on the volume, if the video's looking fine and all of that, then I suppose we might as well just go ahead and kick this thing off. Yesterday the stream was great without music. Okay, the video stream is a bit choppy, but the audio is solid, so it's good. All right. I think that's a new name. Is that Jared? Am I pronouncing that correct, or is Gerard? I don't want to assume. I might sound, might be stupid of me to ask, but you know. All right, I'm gonna turn the radio down just a little more anyways. Video stream is a bit choppy. Yeah, that's what YouTube's saying. It says it's not receiving enough data to maintain a smooth stream, which is really weird. I have no clue. Huh. Stream. Let me just real quick check my I mean, it's connected in OBS. You can just like sign into YouTube, so it should be using the like recommended settings. Max video bitrate. Nailed it the first time. Cool. Sounds good, man. All right, let's go with it. If things start getting like too laggy or whatever, if anything messes up, just let me know in the chat and I will troubleshoot. But for now, I think we'll just see if we can't get this thing going. So this is what we have. Of course, this is what we covered yesterday. This part over here, we have obviously our unified loader here, our LLM prompt here, latent chooser, and then our sampler, brand new sampler. She's working pretty great. I am really happy with this sampler. Out to a preview chooser, and then choppy stream is on and off, but for me it's mostly smooth. Okay, no, I don't think it's a user side thing, because in the back end here you can see it says it's not receiving enough data to maintain a smooth stream, which I have no clue why that would be, but it should be receiving enough data. I have no clue. It's really weird. Because I haven't manually set the bitrate or anything. Whenever you sign into OBS, whenever you sign into YouTube through OBS, it just automatically uses the, okay, now it says excellent stream health. So hopefully it'll stay that way. Everything looking good for you guys? It should be fine now. I think it was something on YouTube's end, because it said that the bitrate was down at like 2900. Yeah. Yeah, I think it should be fine now. If not, let me know. It says excellent stream health now, so should be good. I'm also like running the music stream at the same time, so I don't know if it's like something to do with that maybe, but anyways. So with the FVD, SVD, YouTube, yeah, I mean, it's a Saturday night, right? Isn't it Saturday? Yeah, Saturday night, maybe just bandwidth issues on their end or something. Okay, cool, yeah. Way better, nice. Cool. All right, so we have our Flux set up here. I'm gonna lower this mic just a little so it's not right in my face. And so we output our image from our sampler. We got a latent chooser here so we can Yeah, probably CDN issue. So we can choose one of our images, and then that will go over here to our new FVD sampler, which is still really SVD under the hood. But we're going to add in some Flux stuff right now. So the way it's set up right now on this sampler is, of course, you have your checkpoint name here, SVD XT11, that's the model that I'm using. And of course your steps, your guidance, sampling and scheduling algorithm, denoise, all that stuff is the usual. Motion bucket ID that can control like how much motion is in the output video, frames per second, pretty self-explanatory. Augmentation level injects a little bit of noise into each frame, but it usually results in blurring or like weird artifacts for me. So I usually just leave that at 0. And then the extend count is where we will take the last frame and run it back through SVD to generate a new sequence. Which is where we were running into some quality issues because we lose quality after we go through SVD. So we want to bump that quality back up so our subsequent sequences can be the same quality as our initial sequence. In fact, even better. So here's what we have right now in the code. This is our class right here, pretty straightforward. And so we have our input types. This is everything you see on the node. All of this stuff here. And then we have the main method that gets called whenever you hit the Q button is this method right here, sample. And it gets all of this stuff passed in, which is all of these inputs here. And first thing, it loads up the SVD model. It has the model patcher and the clip vision and the VAE all included in that object that gets returned there. So we can get all of that right out of that model which was loaded. And then we use the model patcher to patch the model. Pass that into our self.patch here, which is this method right here. And after we patch the model, then we can go through and do our batches. So our batches meaning our sequences. So extend count, that is essentially the sequence count. How many sequences do we want to do? So our extend count right here. And while I'm looking at it, this is kind of annoying me because I changed it on the other sampler. I just want to make this say algorithm, not algo. Algorithm. Okay. Algorithm. Okay. Right. So we go through, okay, so we have this print statement here, and then I'm actually kind of just refreshing my own memory here because I haven't even looked at this code since before I did the sampler. So I'm trying to refresh myself here. The initial latent, let's see, none if I is 0 or batches at -1. Right, okay. And then the initial frame is the init latent VAD code on the init latent VAD code on the init latent. Where's the init latent coming from? That's init image. We're passing in an image, right? Init image. Oh, I see. Yeah, right. Okay. So basically, we get an image input. Initially, we get our image that we are choosing from our preview picker. And so that's already an image. It doesn't need to be decoded or encoded. Decoded, I guess. It doesn't need to be decoded because it's passed in as an image. So that is right here, our init image. And we're choosing our initial frame to be either the initial image that gets passed in, which is right there on the first loop. Of course, we want to start with that. And then on subsequent loops, when I is greater than 0, we want to take the last frame of the latent batch that we just created. We go through the first loop and we create a batch of frames. And those are not images; they're like latents, so they're not decoded yet. So we just take the last frame. We take the last frame out of that latent batch, and we use the VAE to decode it. And then now we have a new image that we can start the sequence over again with. So we can get our second sequence. And right in there, that's where we want to. Oh, hi again, bird. Ohio. Bird is the word. That is true. So yeah, like right in here, after we on loops or on sequences 2 and greater, or I guess 1 and greater if you're indexing from 0, we want to start on the whatever the second sequence is. We want to inject some fluxiness back into this thing. And so the first thing we're going to do is we're going to import the brand new sampler. So if you can see, is the text too small for you guys? Can you see everything? I can increase the size of the text if it's too small. Let me know in the chat. I'll leave it right here until somebody says otherwise. So we have our new unified sampler right here, so we can just import that. We want to put it underneath my imports, so we'll just say import, maybe a little bigger. I'm not full screened. Okay, cool. Keep it fluxy. Yeah, we want to keep it fluxy. Yeah, how about that, Baka? Is that a good size for everyone? On the font, on the text. We want to import the FlowState unified sampler. That's what we would like to import. All right, cool. Sounds good to me. We have that going. All right. Okay. So now here's my thoughts. I was thinking about this earlier whenever I was messing around with this. I was making a little loop for the music stream. And my thoughts on this are, whenever we want to, so we get the input image into the sampler, and then we're going to generate the, cool, good to know, bird, thanks. We're going to generate the first sequence, right? And then maybe we just have our extend count on 1. Or, whether we have it on 1 or greater, it doesn't matter. Because if we have our extend count on 1, then that means we're only going to generate one sequence. So we're not going to loop and do more sequences, but even in that case, we're still going to want to pass all the frames back through Flux. So we've generated 24 frames, and whether we want to extend it or not, we still want to at least pass those 24 frames back to Flux. And in order to do so, we're going to be putting them back through this sampler here. We're not going to have like another node off to the side. We're just going to import this sampler into this node. And then we need to send all of these settings, because we'll have generated this image over here, right? Or not right here, but like right here. So we'll have our prompt over here. We have our text prompt. That's going to come through and go through our Flux sampler or our unified sampler. And then that's going to produce our Flux image based on all of these parameters, right? So we're going to need to know what all of those parameters are when we want to refluxify our video frames, right? So one thing I was thinking is I could add another output right here, called params or something like that, and we could hook that directly over here to the Flux sampler, or the Flux Video Diffusion, the FVD sampler. And then it can import its own instance of the unified sampler, and then with the params that came over, it can use its copy of the unified sampler to pass the images back through the Flux sampler. So that's one option, because when we get the image in, we don't have the parameters that generated the image available, so we need to pass them through from the sampler or some other way. But I think that's a pretty straightforward, because I'm keeping track of all the parameters in here inside this sampler anyway. So if I just put one more output here, and then that can connect right up to the FVD sampler, and then we have access to those parameters, right? And then, so I think an example would be helpful. Well, I wish I still had that loop of that guy walking down the street. Let's just try this. Let's jump into our unified sampler here. And right now you can see the return types is just this sampler unified constant that I have defined over in my types. So sampler unified is right, should be like right here. Steps list, where's my sampler? Oh, it's on outputs, duh. Sampler unified, yeah, so we have image latent, and then we could pass, I guess we could just pass a string, or we could probably pass a dictionary. Might as well just go ahead and make it a dictionary. Let's call it like, let's call it like FS params, like that. And then on the FVD sampler, on our input types, we can add that in. So we want to add that probably, we have our seed here. Image width height seed. We can put that, I guess we could probably just put it right at the top. Seed. Okay, we'll say like, or, I mean, well, the other option is we could, the other option is, instead of explicitly passing these parameters over to here, well, the thing that I'm thinking about is in situations where you don't want to first use the unified sampler to generate an image, like maybe you have a maybe you have like a load image or something and you want to just start from there and you don't want to worry about the sampler side of things. Maybe you already have your image and so you're not going to have some kind of sampler settings to pass over, in which case it wouldn't really make sense to have some params being passed in because you're starting from an image. You're not starting from this side of things. So, and I don't want to create like multiple versions of this node. I would rather just have like one that can, I'd rather have one that can be compatible with just like a load image node and with doing it this way. In which case we're going to have to get the, you know, all of these settings for the unified sampler are going to have to be set on this sampler as well. And so do I want to merge these fields with these fields? Or do I need to have separate fields for this part of the sampling and this part of the sampling? I think it would probably be nicer if everything was just here and then you didn't have to pass anything over from the sampler. Although it could be an optional input, so if in case you do have a sampler, you can choose to pass them in if you want. So of course we have our sampling algorithm, our scheduling algorithm, denoise, all of that can be the same. Our checkpoint name, of course, is there. Our min CFG, that is something specific to SVD, and our frames. All of this stuff right here is specific to SVD. Whereas these top fields, these could be either. They could go for Flux or SVD. So what I think is we should just go ahead and include, right, we're not going to need the model type. We already have the sampling and scheduling algorithms. We already have the guidance. We already have the steps. We already have the denoise. Max shift and base shift, we'll need that. And I suppose a multiplier for the latent multiply. And then the rest of this stuff we're not going to need. I had thought about putting this functionality onto the SVD sampler as well, but I mean, especially if you're generating, I mean, it would be cool, right, if you could have every frame in your video, you know, like we had in the stream last night. I don't know if you guys have messed around with the new sampler, but if you caught the stream last night, the you know, the text that you can put on your image, if you have that on every frame of the video, then you essentially have, you know, you have that you have those parameters kind of burned into the video, which is, it sounds nice, but also it sounds like it would increase the processing time kind of significantly. So I don't know, maybe we could include that. Whenever we initialize the unified sampler, we need to pass in all of these parameters here. It would be nice to just pass the model right along. I definitely don't want to have to load up a Flux model again. And the positive conditioning and the negative conditioning, all of that's already right in there. Yeah, you're probably right. I'll put the, here's what I'll do. I'll put the option in there, and, you know, if you want to use it, you can. If, processing. If you want to use it, you can. If not, then you don't have to. But it will increase your processing time, because if you try to, where did our window go here? If you, I mean, it's not a whole lot, you know, it's maybe like a second per frame. But if you're generating like a whole bunch of frames, then, you know, especially because I want the goal for this to be, I want like 30 seconds or a minute or maybe more. I want long videos. And if you're thinking about, you know, say 30 seconds of video at 24 frames, or I guess whatever, 24 or 12 frames per second, I guess we could call it like 12 frames per second for, I don't know, 30 seconds. That's 360, right? 360, 36, yeah, 360 frames, right? So then you got to send all 360 of those back through Flux. And then if you're adding on the parameters and stuff at the bottom, that's going to be another, you know, somewhere around half a second to 1 second per frame for all 360 frames. So anyways, generating video is processing heavy for sure. But yeah, it should be. I mean, like, you're probably not going to be doing this unless you have a substantial GPU. Okay, so I think to make up for using more processing, the Schnell, all right, Schnell and then F4, and then I need to check out that GGUF Flux, the GGUF Flux model. Time is less important than output quality. Exactly. That's exactly my thoughts. I would rather wait a little bit and get some quality results than, you know, SVD is not super slow. It's definitely reasonable, but, you know, I would rather wait a little bit longer and get some quality results. So, okay. I think what we'll do is we either have to add the remaining fields that we need from this sampler onto this sampler, or we have to pass the parameters in there. I mean, in either case, you're going to have to load up a Flux model, obviously, and you're going to have a sampler that can handle Flux. So we're not going to be able to do we're not going to be able to run the sampler in this node from this node. So it's going to need its own internal instance. You know what? I think for now, maybe I'll add it on later, but I think for now I'm going to put an output here that's going to pass the parameters over. And so that way, whatever prompt you use, whatever, you know, the clip attention values that you have there, all of the settings on this sampler, your max shift and base shift, denoise, steps, all that stuff can get passed over to the new sampler. And we might change it later. We might make it kind of like a standalone thing later. But for now, that's a pretty good way to get started. And I think most of the time I'm going to be wanting to start from here anyways. So, all right, so we need to add an input. We have an output on our unified sampler now for, in our types, we added in this fs params. So that's a output type. And basically it means nothing. It just needs to be the same on our, whatever is accepting the input needs to have the same type. So if we have type here, we'll go ahead and say fs params, and we'll set this to, we need to create an input type for it. So we could go with something, it's going to be, I guess, like a dictionary. And it's not really going to have, it's going to have just that special created type. So it's not going to have a default value or anything like that. It's just going to have a type and possibly a tooltip. So I suppose we could just like maybe copy that. And oh, we have a special little section right here for FVD. So let's put this like right here. And we'll call this fs params in, and that's going to be fs params, and we'll make it say flux sampler parameters. Sounds fine. And then, so over here, we can just set that to fs params in. I like having all my types, all of these types. If you have all of this stuff on the node itself, it gets really messy. So I like having them all off in a separate file here. Okay, so we have our type, we have our input there, and we have on the unified sampler, we have our output that we defined right over here. Yeah, but we also need to actually return it as an output. So we have it on the node, but we need to actually return it. So that would be, if we go at the end, right, we're going to get all of our conditioning and stuff, and then we're going to do all of our sampling for all of our different variations of seeds and guidance and scheduler and sampler and all that stuff. We sample all of that, and then we append to our overall batch, and then at the end we concatenate our image and latent batches together, and then we save our params for that run. The params is just a list, so if you look on the object itself, it has params is just a list, so we just appending onto that list. So we need to return that list. Yeah, we're gonna have to return the list because whenever you're running, right, we're gonna output one or more images here to our preview chooser. And then we're going to select the one that we want to send on to FVD, right? So whenever we get over here to FVD, we're not going to know which image that was. Was it number 1, number 2, number 3? How many images were output? Maybe we only output 1, maybe we output 4, who knows? We have no way of knowing from over here. Because this node right here, this preview chooser, this is not my node, so I don't have access to anything within this node. And all I have is that I pass the images in, and then I select one, and I get that image out. So if I'm passing the params over, I need to know which set of parameters are associated with that selected image, right? So what we're going to have to do is we're going to have a field here that will say which image number got chosen. And that way we can select it from the list of parameters that we're outputting over to there. So let's go on to our FVD sampler and let's add a field. We have our params there. I guess we could just do it right under that. We'll just say selected image, and I guess we should create a type for that. We'll call it fs selected image, and then we'll go put that in our types. So that's going to be under the inputs here. We can just do it right there. We have an int right here, which is going to be an int, so we'll just copy paste that, and we'll call this, what did we call it? Fs selected image. Fs selected image, right? and it's going to be an int because it's an index, and our default, we're going to set it to 1. Min is going to be 1. Max, I don't really know. I guess probably under max we'll go with like maybe 10 for now. And flux sampler parameters, and this is going to be image that was selected from the flux batch. Good enough for now. Okay, so we have that there, selected image, and it's an integer, minimum 1, max 10, default 1. All right. And on the unified sampler, we need to return self.params. So we can just go right here and say self.prevparams. And there's a weird thing with whenever you're building these nodes, you'll notice like my return type here in this tuple, I have a like an extra comma and a space right there. And then on all of my types, well, at least on most of them, there are certain cases where you need it and certain cases where you don't. I need to put a comma there. But you'll notice like all of these have like a comma and a space. There are certain times when that's not required, but for some weird reason, Comfy kind of wants a comma space there. Like a lot of things will break if you don't put this extra comma space in there. And I don't remember right off the top of my head where it is and isn't important, but just in case, if you ever have something breaking and you're like, I have no clue why, try putting a comma space on the end of your tuple, and it might just work. So anyways, we have our sampler outputting our list of parameters, and then we have our FVD sampler is accepting that list of parameters, and it's also accepting an integer to tell which of those parameters are associated with the image that was selected. Right? So if we just jump back over to Comfy, let's just do a restart. There we go. Oh, and we broke something. What did we break? We have no module named FlowState Unified Sampler. Well, yes, there is. Oh, right, okay. Okay, well, FlowState Unified Sampler, right. I did that wrong. All right, so up here we need to say at this point the nodes have already ran. Number one question asked when, yeah, exactly, what do we break? So we have the FVD sampler here. That's going to get called in. I would rather not mess with it like that. I think I'll just go ahead and import it manually. So basically the way we need to do this is from FlowState Unified Sampler import FlowState Unified Sampler. And that should do it. My manager button keeps getting moved over here onto the side. I don't know why that happens, but whatever. All right, let's give that a go. Yep, always something breaking. Okay, so looks pretty good. Now, This automatically gets set to there, so we need to get that off of that. And then our FS param. Oh, we need a name for that. That looks ugly. Yeah. So we can put a name on that. On the unified sampler, we have our, let me just collapse that. Images, latents. Oh, we should probably do that as well. Let's see here. I'm going to call this FVD params. This is just the name, so it doesn't really matter what it says. Okay. Okay. Not that this really matters, but, you know, we'll just throw it in there. I need a little bit of music. Let me see if I can get some music going for myself here. Been listening to this song a lot lately. Running up the hill. This song is pretty fire for a... I don't even know when this song came out. Let's give old Kate the... Let's give her the view. This song, so old. 80s music, or maybe 70s, I don't even know. Play some new Yeet. I don't know what new Yeet is, but I'm listening to some old Yeet. Kate Bush. This song for Stranger Things, man, their soundtrack was on point. Alright, so we have our FVD params right there. Maybe we should just call it FS params so it matches. We got a FVD, FS. Maybe we'll call it... and get up to swap our places. August 5th, 85. Yeah. It's such a good song for the, some songs from these periods, like these older periods, just blow me away. I imagine like hearing that for the first time in 1985. That had to be like mind-blowing for so many people. He's an artist, just dropped a new album. He's way too hyper for the stream, probably. All right, I'll check him out. I like hype music, but I just need something to play in my ear for right now. We'll give old Kate Bush a like. I think she deserves it. All right, so where are we at here? Right, so we have our... I think we're going to change that to FS. Make a deal with God, and I'd get him to swap our places. Okay, that'll work. And I'm actually going to pull this over to here. So I can have, I like having an extra tab in this window so I can close out comfy whenever I do restarts. Yeah, man. Music of all countries in the 80s, man. It's just wild. All right, so we have that there. I kind of want this not crisscrossed here. I kind of would rather that be the first parameter. Yeah, let's put that. Let's switch the order on that. Come on, darling. Okay, so we have the selected image. Yeah, we'll put it right there. Come on, darling. Change the areas. The videos are so weird. The reason I was thinking about this song, well, no, I was thinking about this song because, wait, why didn't it switch my order? And an image on top. And an image on top, FTW. Selected image, FTW. Yeah, you don't want to hear my singing voice. For the win. Yeah, for the win. Oh, I was thinking of fuck the world. Fuck the world. Anyways, all right, output, latent image. That's on the FED sampler. Yeah, you don't want to hear my singing voice. That's for sure. I think, let's try this. FS params, init image. Oh, you know what I forgot to do anyways? Selected image, FS params. Oh, duh, I'm stupid. All right, okay. This is the, right. Let me go to my types here. That's on the output. Right, okay. The selected image, and then that's the init image right there. All right then, the selected image is right there. Height and width is down here, init image, and then height and width. Okay. Let's put params. Selected image, params. Let's put both of these down there. Init image. Let's put that there. Okay. I did save that, right? Okay. This guy rocks, man. I've been listening to a lot of this guy lately. Not this. This dude is talented if you guys haven't seen this guy yet. He's the singing voice you want, not mine. Alright, so we have our params. Now we're back in order here. Params to right there. Okay. That's much better. You don't want to mess with me. Alright, cool. So we have our FST. Man, this song is fire, dude. Alright, anyways. Getting too hype. Denoise, seed, steps. So we have our params able to come through here, and then our selected image. Yep, we gotta reset. The thing about whenever you make changes, a cappella on stream, yeah, I promise you don't want that. On the thing about Comfy, whenever you're making these nodes and you add some fields or something, all of the whatever values are in these fields just kind of get cascaded down on top. So if you really want to, you have to go back through and change all these, or you can just do another one. Yeah. So It doesn't really matter. I'm just going to leave that one, but let's just make sure we have everything in here. Steps, guidance, denoise, looks good. The checkpoint name, min CFG, selected image, that's going to be 1. Video frames, 24. Motion bucket, 144. FPS, 12. Augmentation, definitely not 1. And that's fine on 1. Yeah. Alright, so you just got to make sure that doesn't get overwritten. Where did width go? Hold on. Where did width go? We have height. Image width, image height. Am I tripping here? I'm gonna try to turn my AC on. Let me know if it's too loud, but it's getting a little warm in here. Shouldn't be that loud, but let me know. All right, so where did our width go? Init image, selected image, params, init image, params, height, seed, steps. Okay, maybe we need to get a new one here. Yeah. Somehow it disappeared off of this one. Let's get a new one in here. Get that in there. That right there. Unless I was tripping, I didn't see it. So now that is for that, and then we have SVD, denoise 1, CFG looks good, selected image, width, height, right, these are going to be convert to input. Man, this guy is awesome. All right, so we have all of that coming in, and now we can use our selected image to choose which set of parameters we want to use. And so I suppose what we can do is we can try to go ahead and process these frames and just see what happens. All right, let's just try it with one sequence and see if we can generate a sequence of, 24 frames, 12 FPS. So we got 2 seconds of video, and then we'll just try to put those back through Flux and see how they turn out, and then we'll send it into the Film VFI and see what our output video looks like. It should be a noticeable increase in quality. Right, so when we come through, we're doing our loop here. We're just doing one sequence, so this loop is only going to execute once. And Yeah. Let's kind of break this down a little. Whoa, whoa. Let's break that down a line right there. There we go. Hey, sexy lady. All right. So we're only going to execute this loop once, right? So that's our initial frame, and then we get our latent batch, and then we append that latent batch onto here, and at the end, after our loop is complete, oh, I see, the latent out. Yeah, after our loop is complete, we get this latent out right here that basically we just have this batches list is just going to end up being a list of tensors, torch tensors, and so we concatenate them here along dimension 0, which is dimension 0 is just like the frame count, basically. So you have a total, you're gonna have a torch tensor that's gonna be like say 24 by I don't know what the actual latent, usually, well, like your latent image is going to be like divide 8. So if let's say your image is like 1920 by 1080, then your latent of that image is going to be like 1920 divided by 8 by 1080 divided by 8. So it's going to be some smaller number, but just for example's sake, we'll say it's like 24 by, I think the order is like 1080 by 1920 by the number of channels, which is going to be, well, on the latent it's going to be 4 channels, but on the output image it'll be 3 for RGB, red channel, blue channel, green channel. So on the latent though, you have 4 channels, so it's going to be something that looks like this row right here, and your tensor is, and so your batches is going to be a list of those torch tensors that are like this shape, and then so we concatenate these all together along the 0 dimension, which is just the frame count. So we're going to have 24 frames, and then if we do a second sequence, then we'll have another 24 frames, and then another and another, and so then we eventually concatenate them all along this dimension. We're going to get, let's say we have 4 sequences, then we would end up with 96 frames total. So then we would end up with our output, once we do the concatenate, then this would look more like 96. So we would have, say, like, if we have four of these tensors like that shape, then we're going to concatenate them all up to just be one big tensor like that. And so that's what we're doing right here. We're concatenating this list of tensors into one big tensor. Of course, it'll just be one if we only did one sequence. But anyways, that's our latent out. The way that Comfy wants your latent out, like for example, on the preview chooser here, or any other node you see that accepts a latent batch, some type of latent, it's going to be expecting it like this as a dictionary with the key samples, and then whatever your tensor is there. So that's our latent out. We batch up our tensors and we make our latent out, and then we can decode it. We just got a little print statement here to let the user know we're decoding. Then we take our VAE and we decode that. Now we're gonna have to decode once, because this VAE is not the Flux VAE. This VAE is what we loaded from SVD. So we load up the SVD checkpoint here, and it comes with its own VAE. So that's what we're using for this. Although I suppose, yeah. So we'll go ahead. We'll try it a different way later. But for now, we're going to go ahead and use the SVD VAE to decode this batch of 24 frames. And then once we have those as images, we can input those into the Flux sampler. So we have our unified sampler right here imported. And what we're going to do is, at this point, after we've decoded the images, we're going to, we have image out and we're returning latent out and image out. That's enough. But first we want to intercept these and decode them, right? So let's make this easy. We have our params, which we actually need to accept in our method here. Right, so we have our selected image and our FS params. We need to accept those. So, do you play games? You know, I've thought about doing some game streams now that I have this PC. I'm not really like a big gamer. I used to play Halo. I like Halo. Halo's cool. But it's been forever, really. I mean, I did play a couple years ago. I did play Halo Infinite, just because they had like a free thing where you could just get it for free, basically. Or I think I might have paid like $10 or something for it. But yeah, I played Halo Infinite. That's the last game I played. And before that, I hadn't really played any games since like Halo 3. But I really like the story and the visual effects and everything in Halo. It's pretty badass. I don't really like I never really got into the like multiplayer, like just shoot it out kind of thing. I really like the campaign with the story and you know, you're going on sniper missions and like, you know, it's more realistic than just an all-out, you know, shootout in some arena. But that's fun too sometimes, I guess. But I'm especially open to suggestions for free games because I really don't want to pay for games right now. And I would like to do some game streams. I think it would be kind of fun. You can kind of just like fuck off and, you know, hang out, play some games, whatever. Maybe drink a little bit, have a couple beers, and you know, people have fun with that stuff, and people watch that stuff on YouTube, so why not? What games you playing lately, Baka? Right, we gotta accept our inputs here. Right, init image. We're already accepting init image down in here. We need to also accept our selected image and FS params. And we might as well just jump down onto the next line for that. So we're gonna call that init image we got. We'll go with selected image and FS params. I wonder if he has a track list here. This is I don't know how to see who it is, but I would definitely suggest listening to this guy if you guys like remixes. There's a lot of free casual fighting games. Yeah, exactly. Playing with viewers, stuff like that. I think that'd be pretty fun. Counter-Strike. Yeah, I've heard of people like Counter-Strike. I haven't, I don't know if I've ever played it, but... Right, so we have, let's put this on that line. Fallout London. Not free... Oh, it's free, but depends on a Fallout 4 install, which is not free. Okay, cool, I'll check it out. Fallout is, well, yeah, that's like the apocalyptic, that's the one they just had a show on, right? There was like a season 1 of that, I'm pretty sure, right, with the God, I can't remember the chick's name with the big eyes. Yeah, the show was freaking awesome. And my cousin was making fun of her eyes. He said she has golem eyes, but I was like, nah, I love those big ass eyes. Like Disney princess eyes. Like, whew, she got them big eyes. Anyways, sidetrack, I guess. And I just like her demeanor in the show. Like, obviously it's a character. It's not like how she acts personally, but like her demeanor, she's all like, at the beginning at least, she's like, yeah, exactly. And just her, like, her personality where, exactly, yeah. She gets her new, like, husband assigned to her or whatever, and he just, like, I can't remember exactly. It's been a while since I watched it, but basically he makes some, like, gesture of, like, I want to, you know, smash. And she's just like, oh, okay. Like, she's just so, like, happy and goes along with everything. I was like, that's pretty awesome. That's pretty chill. Anyways, huge tangent. Definite sidetrack. Ella Purnell, yeah, that's her name. Yeah, she's pretty great. That show overall was really good. A lot better than I was expecting it to be. And another show that's coming that I've been waiting for season 2 of for like 2 years now is Severance. I don't know if you guys have seen Severance, but that show is probably my favorite show right now. That show kicks ass. And I guess there was like the writer's strike thing or whatever that was going on, but it was like 2 years or maybe more delay from season 1 to season 2. And I was like, I know they have to make a season 2. There's no way they're canceling that show. It's such a good show. It's like an Apple original thing. And yeah, they're crushing it. A lot of Apple shows are pretty fire. Yeah, Severance is dope. And that, especially with the freaking season finale, that cliffhanger where she's on stage and she's like, yeah, they torture us down there. And it's like over. And then 2 years later, you're like, come on. Yeah, season 2 in Feb, I'm pretty sure, yeah. They finally announced. They didn't even announce it forever. I was just like, we're just sitting in the dark. And it's so annoying. But yeah, that show is awesome. They're doing a couple of good shows. I think they had, what's that sci-fi show? The, I guess that's a sci-fi show too, but the Foundation series, I'm pretty sure that's Apple too. They had a season 1 on Foundation. That was pretty good. Cleon, Emperor Cleon, he was pretty badass. Well, I guess he kind of varied. He was badass at times and kind of a loser at times too. All right, so we need to decode. We accepted our parameters and our index into our parameters, the selected image. So we need like associated params. And I guess really this could go up top. Or I guess, no, we're going to want to do this, we're going to want to do this on every iteration of the loop, right? Because, no, I don't really want to do it on every iteration of the loop. I mean, I guess it doesn't really matter. Last of Us. I don't know if I've seen it, but I'll check it out. Nice, yeah. They canceled Halo too, which I kind of don't mind. It was an okay show, but they were taking it off in a weird direction. It's the best Halo show I've seen so far. But somebody really needs to take Halo and do something good with it. A show or a movie or something. It seems like it would be like a huge moneymaker. I don't know why they haven't done that yet. Right, so I guess we could do this every iteration of the loop, right? We could, regardless, we're going to have to, so for each sequence that we generate, obviously we're going to have the initial frame, and then the sequence, and then the final frame. And the final frame is going to have to get passed back through Flux before we can go on to our next sequence. So that has to be done on every iteration of the loop. But that doesn't necessarily mean that we need to do every frame in the sequence on every iteration of the loop. It might be better to just wait and do them all at the end, although then you got to keep track of which ones you've done and which ones you haven't. I think it might just be easier to well, the selected image is only going to be on the very first image, so the remaining ones are not gonna, they're just going to be pulled from the last frame of the sequence. So I think what we're going to do is we're going to get the params up top whenever we first come into this method here. This stuff right here is our SVD related stuff. So I guess we could put it above or below this. It probably doesn't matter too much, but let's just put it right here. So our associated params is going to be our, say, FS params at, because our FS params is going to be a list. It's going to be a list of parameters. And let's think about this. If we had, let's say we generate 4 images right here, and we select number 1 to be passed on to FVD. So then our params is going to be a list of 4 sets of parameters, and the devs that have been making Halo rebranded, they're doing some new interesting stuff, including 2 new Halo games. Alright, cool. Yeah, I like Halo, man. I need to replay through. I think my cousin told me they have like maybe $50 or something. You can get all of the Halo games on PC. I was like, yeah, that sounds pretty good. I'll do that. Unreal Engine 5. Yeah, cool. I don't know the difference really, but I haven't. Game development is something I would like to get into at some point, but I definitely have. I'm familiar with Unreal Engine, but I don't really know a ton about it. So if we select image number 1, and our list is going to be, say, a list of 4 sets of params, then that'd be like 0, 1, 2, 3. So we would want, I guess it would just be associated, just -1 would be fine. So let's say if our selected image is 1, then I guess we could just say selected image -1. Yeah, it's I mean it's very intensive. Game devs are, you know, they're as skilled of programmers as anyone else, really, if not more so. There's a lot of I mean, even like physics, and there's a lot of stuff that plays into game dev that you got to be pretty smart for sure. And you got to be willing to, I mean, it's like any other type of coding. Like, you just got to be willing to sit there and stare at the screen for 12 hours, tearing your hair out until you get one little thing to work right. And then do it again for another 12 hours and another 12 hours and repeat until you finally have a finished product. Okay. So we have our associated params. These are the parameters that are associated with the initial image. And we could, yeah, so at the end of each sequence, we'll have a, I don't even really need to store this as a list, but it's fine, yeah. At the end of each sequence, we'll have a tensor. That will be our latent batch that we get back from this common K sampler right here. Yeah, so that's going to come back. We're going to put that, we get it back as a dictionary as a tuple with a dictionary that has the key samples. We get that out of there, and then we're appending just the tensor onto this list, so it's no longer in a dictionary. And so at that point, we can go ahead and run our, we might as well go ahead and instantiate a, yeah, we might as well go ahead and make a, let's call it like, say, Flux sampler is going to be a new FlowState unified sampler right there. And this doesn't take anything in the initialization function, so you just need to declare it and call it right there. So we initialized our new sampler. That's pretty easy, right? It's only, you know, like 600 lines of code right here, in one little word. Cool. So we got that. And then we need to call its execute method, right? And we're going to have to pass in all of the stuff that it needs, which is all of this stuff here. So I suppose, well, actually, we don't really need, you know what, now that I'm thinking about it, we don't really need all of this stuff, because we don't need to run through all of these things again. We're just going to have one set of parameters with one set of values. It's not going to have like all of this stuff. It's not going to have like multiple seeds and multiple guidances and stuff like that. It's just going to be one set of parameters. So we don't really need to call the execute method. We could call maybe the sample method. Or we could just call the sample flux method, make it really easy. You know what, we could just do that instead of importing, because we don't really need, now that I'm thinking about it, we might not, I think if we just, let me just copy this method right here, and let's put it right directly on here instead of importing the, let's go right here, and let's call this sample flux right here, and we got to get our imports from the top up here. I'm just gonna get all of this crap right here. I don't need that. I just need like maybe this stuff right here. And there's nothing else over here, right? I think, well, just to be safe, what I'll do is, I think I'm just gonna get rid of this. And we'll put this right here. Where did my music go? It's over. Work with Batman? No, thank you. Summer DJ, Afrojack, Chainsmokers? Nah, I don't really feel it. Let's do another sick mix. No Grammarly. Sick. About rolling down in the deep. Man, this dude is so talented, I have to say. It's pretty great. Like an astronaut in the ocean. Alright. What did we have imported down here? We had time, torch. We probably want copy, comfy utils. We have SD, folder paths. We're going to want folder paths and warnings. Do we not have warnings up here? We must have. Yeah, right there. Okay. So we got time. We got torch. We got utils and SD. And we got warnings. So we just need to get folder paths. And common case sampler. And we already got that right there, so we'll get rid of that. Down in the D. I would like to do some music remixes too, as like some mashups. That stuff looks really fun. All right, so now we have the sample flux method right here. Instead of importing the unified sampler, we're just going to call, because we just need the seed model, positive conditioning, guidance, sampling, scheduling, steps, denoise. We need the max shift and base shift. Yeah. Okay. All right. Well, I think this will work. I don't think we actually need to import the unified sampler. So that should be fine. Okay. I tried to show him. I gotta run to the restroom real quick, guys. I'll be right back. All right. My bad. I was holding it for a while there. All right. Back it up, you. All right. Back it up. Lay down. Lay down. Lay down. Like I'm MB Dix. Bitch, I moved through London with that Euro step. I'm still a dog. All right. What's my... Yeah, it seems fine. Okay. That white shit don't never stop. Right. So after we append our batches, or maybe we can do it before. Yeah, we might as well. Oh, well, we're doing our decode down here. Okay. So if we're doing our decode down here, the goal here is to really just touch up our image, right? So as an example, if I had, let's say if I had this image right here, but it was kind of like bad quality, and I have this as my latent image, and I have a prompt that describes what I want to see in the image, and then I turn my denoise down, I don't really need to do a whole lot of steps. And obviously I don't want my denoise on full. I don't want my denoise to be 1, because I really want this. I'm trying to correct like aberrations or blurring or whatever bad quality that's coming in through this image by generating another one on top of it and blending the two together. So that's what we're doing over here, because SVD is going to decrease the image quality. So we don't really want to change the image at all. We just want to like touch it up. And so the point of that is that we're not going to want our denoise at a full value, and we're not going to want our as a matter of fact, I don't even think it's relevant to have a denoise field here on the sampler, because there's really no situation where you're going to want less than 1 denoise on this. I mean, you're always going to want to denoise your frames, except for whenever you're passing them back through Flux. So I might take this denoise field off of here. It doesn't really make any sense. For now, I'm just going to leave it there at 1. But so that's the like SVD denoise. That's not the Flux denoise. So I suppose we might as well do our decoding. We're going to have to at least decode that last frame. And I don't really want to just decode the last frame and then have to figure out at the end, okay, now we need to go back and decode the rest of the frames and then stick them all back together. And it just seems like kind of a mess to do it that way. And I think in terms of processing speed, it really shouldn't make too much of a difference whether we decode every sequence or whether we decode once at the end, because you're still decoding the same number of frames. I mean, theoretically, it might save like a couple seconds, but like that's like a couple seconds overall, not like per frame or anything. So I don't think it's really going to make a big difference. So what we're going to do is at the end of our loop right here, before we append our this latent batch right here, this is our latent batch of frames from SVD. So this patched model, that's our SVD model, and it's getting sent into the common K sampler, and then so the sampler is going to use the SVD model to produce our 24 frames. So that's what this latent batch is. And again, that's on a dictionary that has a key called samples. So here's what we're going to do. This is our latent batch, and I'm just going to say video. Do I already have video frames? Video frames right here. That's the number of frames, right? Okay, so I don't want to have that. We'll just call it latent frames. Do I already have latent frames? Jesus. Where's that at? Did I define that? Oh yeah, okay. Latent frames. We have our positive and negative conditioning, encoded components, self-encode. That takes our initial frame. Oh, okay, so this is our, okay, I see, I got you. All right, cool. So this encode here, this is taking our clip vision, and this is producing the initial batch of 24 latent frames that get passed into our common K sampler here. So instead of calling this latent frames, I'm gonna call it God, that's loud. Holy shit. I'm gonna call this whatever, we'll call it latent samples. How about that? Latent samples, latent batch. Yeah, we'll call it latent samples. Alright, so latent samples is just going to be this right here. And then what we're going to do is we need to decode them. So that's going to be this right here. Whatever. VAE.decode the latent samples. Right, so now we have our images as frames, right? And I guess we need to assign that to a variable. Let's say, you know what, let's do it like this. Let's call this sequence latent, and then we'll call this sequence images, right? So we have sequence latents that we get out of our latent batch that we got back from our K sampler, and then we have the images, which are the decoded latents. And then we need to, I guess we need to just pass them all back through Flux, right? I was kind of thinking of this as just doing the last frame, but we're going to be doing all of them anyways. So yeah. So if we look at the sample flux method that we copied over from our unified sampler, these are what we need, right? So let's just go ahead and copy this whole thing right here. And we'll say sequence flux images, maybe. And that's going to be self.sampleflux. And this shit is fucking fire, dude. Alright, anyways. Seed. Right, positive conditioning, guidance, algorithm, scheduling, steps, denoise, max shift, base shift. And that thing is returning, this is going to be the latent. Yeah, so we're going to get a latent batch from that, and we got to decode that as well. So we need our Flux VAE, which is fine. We'll just go ahead and we could have that as an input as well. Seed, steps, guidance, init image, selected image. Bees in the trap. Alright, so we got FPS, video frames. I guess we could just put it right there. Yeah, sure, why not? We'll call this Flux VAE, and I'm pretty sure I can just say this is a VAEN, yeah, because over in my types we have should be right here somewhere, VAEN. Well, I know it's in here. Okay, there it is, right there. So we have that type right there. So that can be, that's fine. FS params. So down here we have our FS params. We need to accept that. Flux, VA. And then, so we have our, this is not going to be images, this is going to be latents. So sequence latents, let's call this sequence SVD latents, and then we'll call this sequence SVD images, and then we got sequence flux latents, and the model that we're gonna pass, we need to get our model from there as well, which is our model's not gonna be on the params. So we got to pass our model pipeline through. Or we could just choose to load it up, but the problem is it's not going to be, like for me that'll work, but it might not necessarily work for everyone. If you're using NF4, or if you're using Schnell, or if you're using a GGUF, however you say that. So to make it work for everyone, I think we just need to accept it as an input, and then you can choose whatever Flux model you're using. The only other option would be to package a Flux model with it, and that's like 10, 12 gigs or something like that, 20 gigs, depending on which one you're using. So I think that's maybe not advisable. So let's accept it as an input. We got more inputs. So we got our Flux VAE. We might as well put that right here. Flux model. And we are getting a little long on this line, so let's drop it down to the next. So we got our Flux model and our Flux VAE, and we need to accept that in right there, so we'll put that in as that model, and we gotta have that already somewhere over here. On our input types, we have the model type and then the model in. That's what we want. So if we come over to here on our Flux model, model in, that's the one. And on our model in, it just looks like, should be like right. Yeah, it just looks like that. So it's just a model type, and well, I guess it's not going to be an SD model, but you know what, just to be specific, explicit, let's just copy that and we'll put it down here. We'll put that right there. Model in, we'll call it Flux model in, and input Flux model, and then that way it's explicit. Flux model in. Yep. Okay. All right, so now we can pass our model pipeline through there. And if we're looking over here right now, that just goes to the sampler, but it could also go over to here. So this use anywhere node is like specific to that sampler. So what I'm going to do is just delete that, and we'll use one of these other ones that goes everywhere. So now anywhere that has a model, it can accept that. Right there will do. Alright, so now the model should still be going into right here. And when we refresh, we're going to have a model input right there as well. And that'll be our Flux model in right there. And so we are going to need to call this Flux model. And now we got to get our parameters out of here. So we have associated params is that, maybe I'll call it like init image params, just to make it, I think it's a little more clear. And so out of there we got to get all of these things, right? All of these things that were used to generate the initial Flux image, we need to get that out of there. And actually we don't need to pass self right there. What we need, pop that down on another line right there. Okay, so we need to get things out of here. And so we're going to say flux seed equals init image params at seed. I'm pretty sure it's just called seed, but we'll double check just to be sure. And then we're going to need a whole lot of other things. We got our Flux model, so there's that. That's passed in. We need our positive conditioning, which I believe is called positive conditioning, right? We have do we even put the conditioning? We don't put the conditioning on these params, so we're gonna have to add that, which I guess is fine. I don't see any reason why that would hurt anything, really. It shouldn't break anything, right? Because we're getting our positive conditioning right here. Well, you know, we don't necessarily need... Yeah, let's just leave it. We'll leave all of this stuff here. We got seed, we got height and width, sampling and scheduling algorithms. All right, so we got our steps. Cool. Yeah, that works. Max shift, base shift, and then we just need to do our... You know, instead of messing with this params object, because I don't want to break anything, I'm just going to create a new one. Right here, I guess. We don't need this stuff. Yeah, we don't need that stuff, and yeah, so let's just say right here, before we alter this params object, let's go ahead and make a copy of it. So we'll say like FVD out parasma equals a copy dot deep copy of params. And then we want to also say FVD out params at positive conditioning equals positive conditioning. Yeah. Okay, so now we have a copy of this params object here, and we've added our positive conditioning, so when we pass this over, we'll be able to pick that up out of here. And we already have the seed on there, we already have the guidance, we already have the sampling and scheduling algorithms, steps, denoise, latent batch. Oh right, this latent batch is going to be that latent batch, right? Yeah, that's fine. And then we have our max shift, base shift, all of that stuff is on there already, width and height. So we can just take it out directly like that. I'd rather not unpack all of that. You know what? Why don't we just, instead of unpacking all of that right here, let's just, yeah, I'd rather not unpack all of that here in this main method. Let's just go ahead and say init image params. I can... init image params is going to be that. I think that should probably work. But let's do it like this. Let's go ahead and say, let's pass init image params into sample flux, and then we can unpack everything in the sample flux method, because there's hardly anything in here anyways, so we might as well use up this space instead of clogging up this main function right here. So right now we're not getting all of this stuff passed in. We're gonna take all of that out, and it's gonna be init image params. Oh man, there you go. Everybody go. Where'd he go, boss? Where you go, boss? All right. That's weird. Anyways, so we have 5013. All right. So yes, we need to paste all of that, and then we have. We might as well just go ahead and break it all down. Like so. And I feel like, yeah, okay. And then we'll just get all of this. Copy init image params at whatever that is. Oops. And we'll get rid of that. Except down here, we need to put that back onto there. All right, so now we can get all of that stuff out of our params. I wonder if we could pass the model along. I don't see any reason. Oh, this one is going to take several days for sure. Several days of like me being very dedicated, like pretty much all day, every day for several days. It's going to be, if you want to think about it in hours, it's probably going to be 100 hours worth of work, I would imagine, total. Roughly, maybe 60 to 100, somewhere around in there. Like most of the nodes, you know, simpler nodes you can do in just like an hour or something, but like something like this or the unified sampler that I just made, it was for sure 100 hours worth of work to do that unified sampler. And it's going to be similar on this one. Yeah, I mean, it's a full-time job for sure. Yeah, I mean, I have my own selfish motivations too. Like, I want this for myself. But I feel like, you know, once I make things like this, I get wanting to sell stuff and make money off of it. But whenever I make something like this, whenever I get done, I'm just like, I mean, it's a digital asset, so it's not, you know, it's infinitely reproducible. So what do you charge for something that's infinitely reproducible? I don't know. It seems better to just give it away. So I guess I'm kind of a man of the people in that sense. But it just seems wrong to charge for most software. There are exceptions. I know there are like software companies where, like, I don't know, say AutoCAD or you know, some like thing that took teams of engineers years to make. Yeah, I would sell that. But for me, you know, if I can get something done in a few days or a week or something, I don't really see that should be sold. Columbustine. Those guys are hilarious. Okay. All right. Yeah, exactly. Plus, like, I feel like selling things kind of inherently diminishes creativity. If you want innovation and you know, innovation or invention or whatever they say, like invention is what do they say? Necessity is the mother of invention or something like that. You know, people make the best things because they need them, not because they are trying to market a product, right? Like, I saw this thing, I think it's called like Zipline or something like that. It's some African country where they needed to get like food and medicine and stuff to remote villages, and this small team of people came up with this thing. It's like a drone delivery service, but it's like the way they have it set up is crazy efficient. I think it's called Zipline if you like YouTube it. I'm pretty sure Mark Rober, the what's his channel called? Something engineering something. Anyways, Mark Rober, I'm pretty sure he did a video on it, but yeah, it's just like such an impressive little thing that they have going on, and it's like they needed it, so they made it. So anyways, I feel like whenever you start marketing things and selling things, you kind of kill that that inherent need to create, and then, you know, creativity and innovation gets stifled. So the more things are open and free, the more people can be creative and play around with things and be like, I need this, so let me make this. Like, you know, me making that unified sampler or making this FVD node. It's like, I need this thing, and I'm a creative person, so I'm going to make it. Whereas if all of this comfy stuff was like proprietary and closed source and sold at some kind of, you know, expensive price, then I would have never been able to come along and build these other nodes that I'm building on top of this platform, you know? So when you start closing things off, it diminishes creativity. So that's like one of the primary reasons why I want to keep things free as much as possible. Free and open source. I mean, like, I can show my code here on stream. I don't care who copies it. It just, like, overall for the community, I think that's the best thing to do. So I suppose we can pass our model along as well, and then we don't have to have that as an input. Now that I'm thinking about it, we have this Flux model in. We don't need to do that. We can just probably just get rid of that, right? And the VAE, I mean, we're getting the VAE over here too, so we might as well just pass that along. Get rid of that. Bad. My bag. I'm assuming you meant bag, but yeah, me too. I definitely, like, I try to keep a good moral compass, but I also want money, so I'm not just gonna, like, you know, a lot of people are too, yeah, bag. A lot of people are too altruistic to the point where they, like, you know, get taken advantage of, and I definitely don't want to be that, you know. You don't want to be too greedy and you don't want to be too naive, so you got to be somewhere right in the middle. I still want to make my money for sure. So on our params copy, you know what? Because we already get the VAE right there, and we already get the model right there. So let's just go ahead and put that on there. Yeah, I believe we will. Model. And VAE. Alright, so we can just pass that right along. And FVD out params. Make sure we're passing this back. Yeah, params, but we want, okay, I can just add it to the end here. FVD out params, that's fine. And then make sure we're accepting that right here, I suppose. As a matter of fact, you know what? Yeah, because we're going to want to have access to that positive conditioning. So, which right here, positive conditioning is a list. So we need, right now we have image out, latent out, params out right there. And last image batch, last latent batch, self-prev params. So we're passing that back already, I suppose. Okay, let's we have params out. Params out append equals params out plus equals params out. And that is happening, that's inside this loop, right? Yeah, okay. No, it's not, it's outside the loop, okay. Right, yeah, okay. Okay, well, if we're returning that, what do we call it? FVD. Params out params, whatever. FVD out params. We'll just do that right there. FVD params. Or we'll call it, yeah, whatever. Out. We'll just call this FVD params. FVD params. Way up here, okay. FVD params, what do we call it? FVD params out, yeah. Okay. Right, I suppose we need to do like that. Do we really need to? Yeah, I don't think we actually do. I think we can just do that and we'll return FVD params out. Okay. So now we're returning those params, and then we should be able to access them over there. So let's do a little test. Let's see if we can't get hold of those params and make sure they're the right ones over in SVD, or FVD. So I think we should be good. We're just making a copy of the params here, and then we're putting our model VAE in positive conditioning. These are the Flux model, the Flux VAE. So basically what this is saying is whatever model, whatever Flux model and VAE you used right here, that's going to get passed right along to here. So we don't have to have an extra like model pipeline coming all the way over to here, or like out of here and coming over to here. It's just going to be in the params. And that should work fine. I don't see any reason why it wouldn't. So yeah, that should be fine. So we should be able to close that up and close this up, I believe. And then just know that we're returning now this FVD params out, which is going to be a list of parameters that include the VAE and the model. So if we close that up and we go back to the FVD sampler, now we don't need to accept those things, we just need to accept the params. And I guess we can put this back up on that line since it's not too long now. And then make sure in our, we have the FS params, and that's it, right? Selected image, that's all we need. And so we have all of this stuff here. I don't know that we really need to get it out, but we have the model. We might as well go ahead and get out the VAE. Yeah, we might as well. So we have the seed, the model, the VAE, the positive conditioning, guidance, sampling, scheduling, steps, denoise. Now, here's the thing, our denoise, we're not going to want to use that. We're going to set our own denoise here, which is going to be denoise. We're going to set it, we'll play around with this. We'll have to play around with this to find out what a good balance is, but for now we'll just set it to 0.88. And so we have our seed, max shift, base shift, height, width, positive conditioning, guidance. Our guidance, right, the guidance we get out right here. Yeah, okay. And then our guider, patched model with our conditioning and our sampling algorithm, patch model. I think all of this should be fine. Sampler, custom, advanced, sample. Yeah, that should be fine. The only thing we really need to override is the denoise. The max shift and base shift can be what it was, and the height and width obviously need to be what it is. And yeah, I think that's fine. Okay, so this seems fine. So basically what we're doing here is at the end of our, this is where we go through SVD, and then we get those latents out, and then we decode them and produce images. And then we need to get, I guess we could return the latents also. Yeah, we might as well go ahead and do that. And we don't actually need the VAE out of here, right? We're not using the VAE anywhere. Oh, that was supposed to be VAE anyways, but we're not using that, so we can cut that out of there and just put it down here. I mean, we could just do it all in there and just return both. Yeah, we might as well. Let's just do that. So instead of returning that, we're just going to say this is going to be latents, and then we will say images equals VAE decode the latents, and probably, oh, we already went ahead and got it out of there, so that should be good, right? Because we already got that out of there. Yeah, I'm pretty sure that's fine. Let's take a look at this again real quick. When we call sample flux, what we're getting out is just going to be a tensor. Yeah. Yeah. It's just going to be a tensor. So we're getting it off the dictionary already right here. Just wanted to make sure. So we don't need to worry about that right here. We can just pass that straight into the VAE decode. And so then we have our images. Oops. And okay, come on now. I don't want whatever this is. Right. Okay. And then we can go here and just say return our latents and our images. Yeah. Okay. All right, so we'll sample flux like that, and then we should sequence flux latents and sequence flux images. We should be getting that back from there. So now we get so now we're doing our SVD sequence, and then we're doing our flux. We're doing our flux. We're doing our sequence, and then we're doing our SVD sequence, and then we're doing our SVD sequence, and then we're doing our flux. So now we're doing our SVD sequence, and then we're doing our flux. So now we're doing our SVD sequence, and then we're doing our flux. We're doing our flux processing on all of the images in all of the frames in the sequence. So now we have a set of flux latents and flux images, and yeah, that works pretty good, because then we can just say batches append. Instead of batches, what we're going to do is call this, we're going to keep these separately. We're going to say like sequence latents, and then we'll keep another one called sequence images. And these will just be a list of tensors. And yeah, so we'll just take these and, oh, this needs to, we got sample flux sequence SVD images. Oh yeah, that's right, we got to put that in there. Okay, yeah, init params, and then we got to say comma sequence SVD images. Yes. Or, you know, we don't even, do we even need to decode that? We might not even need to decode that. That might be an extra decoding step that we just don't need. We'll try it both ways, but my thought is, instead of decoding the latents, the SVD latents, and producing images from the SVD latents, and then passing those images, because then we would have to encode them again, which, you know, I mean, maybe we need to decode them and then produce images and then encode them with the Flux VAE instead. But I'm not sure that we actually need to. I think the SVD latents for the sequence, I might be able to just use the, let's just try it like this at first, and we'll play around with it. Okay, so we're gonna use the SVD VAE, which maybe I should make that more explicit. We'll call this SVD VAE, just so it's clear. Excuse me. So we have the SVD VAE. We're going to decode the SVD sequence latents, and then we're going to pass those latents in. No, so we're going to pass the images, the decoded images, in to our sample flux. And we no longer have batches append, we now have sequence latents append. Let's say we can get rid of that. Say sequence latents dot append. Well, yeah, sequence latents dot append sequence flux latents, and then we'll also do the images. Yeah, sequence images append sequence flux images. Just put a space there, make it a little easier. Okay, so that sounds fine, I think. And obviously these batches got to change. So the initial latent, right, none if I is 0, batches at -1, video frames -1. Right, video frames -1, because that'll be at the end of the sequence. So I suppose I don't think we even need, because it's always going to be an initial image now. We don't need to do the decoding every time. because we're already doing the flux decoding, so we already have a batch of flux images being tacked onto this list at the end of every iteration. So when we come back for loop 2, we don't even need to worry about this. We'll just go ahead and, well, we need, I think, let me just go ahead and comment that line for now, and then what we'll do is we'll say it's the initial image if I is 0, else it's going to be, we don't need to decode, we just need to get, say, like this. Oh, jeez. That's not what I wanted to do. We need to say sequence images at -1. So that's the last image in the frame, or the last image in the sequence. Video frames -1 will be the last, well, sorry, sequence images will be the last batch of sequence frames. So if we just did one sequence and then we did another sequence, now then, you know, we're moving on to the second sequence. Sequence images at -1 is going to be the last sequence, and then video frames -1 will be the last frame in that sequence. And then automatically, whenever you try to slice a tensor like that, it's going to, if your first dimension is 1, then it's just going to get rid of that extra dimension, and so we need it in a 4-dimensional tensor. So we got to unsqueeze. This unsqueeze 0 just adds a dimension in the 0th place. So that's all that does. It just makes something that we're gonna have whenever we get the last frame out of the sequence right here, like this is going to return us something that looks like, say, like, I think the order is like backwards, but it's like 1080 1920 by 3 or something for RGB 3 channels. And what we want is 1. We want an extra dimension there. So that's what this unsqueeze method is doing right there. So yeah, the initial image is just the initial image. Unless we're on sequence 1 or greater, then we got to get the last frame from the previous sequence. And yeah, okay, that should be fine. And then there's the init frame. All of that's going to be the same. SVD, width, height, all that's going to be the same. Motion bucket ID, augmentation level, that's not going to change. Get those conditionings, get the latent frames, common K sampler, patch model. All of that goes back through SVD, through the K sampler. And yeah, so I think this should be fine. Latent batch 0 samples, the SVD VAE we decode, and then we pass those in. And then, okay, and then so down here we are going to concatenate our, yeah, I suppose we probably should do that, yeah. So our sequence latents, so this is going to be sequence latents. Dimension 0 should be fine. Latent out, yeah, add samples, right? Okay. And now this VAE here, we don't really even need this anymore, right? Because all we need to do is concatenate our images just like we just did with the, yeah, we just need to do, it's already all decoded by this point, so we just need to concatenate all that stuff together. Like so, except on sequence latents, this is going to be sequence images. And yeah, the rest should be fine, I would think. FlowState FVD sampler. The shapes are going to be the same. One thing I did want to do, I don't like having my time displayed in seconds. It's pretty annoying. So let me just copy that. And we have here, let me just paste that into right there. Right. So instead of param sampling duration, we're just gonna say get rid of all that. Sampling duration, we have a start time up here, right? Yeah. So sampling duration is going to be time minus start time. Sampling minutes, yes, of course, we got to change that too. Yep. So sampling duration, time, minutes, seconds. Yeah, I like that better. And nothing's really changed here. I don't think that's... Yeah, I think that's fine. So we can get rid of that one. Alright, so generation complete, total generated frames, latent out, samples, shape, output resolution, that should be fine. Generated time, oh, generation time, yeah, that's what it was, actually. Let me go back. Give me this back. I want that. And then I can get rid of that. And we can put that in. Nope, that's not what I wanted. Yeah, me too, man. I don't know why anyone hasn't thought to do this. I mean, you're just using SVD as normal and then just touching up the frames at the end with Flux. It's I don't know, it seems pretty like a obvious thing to do. Instead of being stuck with the SVD image quality, you might as well get Flux quality. Adds a little bit more processing time, but who cares really? I prefer the quality. Yeah, it's gonna be nice. We need a better model than SVD in terms of generating the sequence frames, because it would be great if we could. SVD is not bad, but you'll notice with SVD, a lot of the time it's going to generate these kind of like either panning or like rotating shots. So whatever your subject is, if your subject is a person, SVD is going to kind of do a rotating shot around your person. Like that's what it does a lot of the time. I mean, it's not a matter of Flux and SVD working. Flux and SVD are doing their own separate things, and the only place that they really come together is like right here on this couple of lines of code. So up to this point, it's just SVD doing its thing, and then it just decodes the images that it produced. You know, so you get a batch of images, and then the batch of images, you can send that anywhere. You can do Flux or whatever else you want to do with it, because it's just a batch of images. So like in Comfy, how we use the input images as latents, that's literally all we're doing. We just have a batch of images that happen to come from SVD, but there's nothing special about them that makes them, you know, like specific to SVD. They're just a batch of images, just like this or any other image. So you're just taking those images and passing them right back into a Flux sampler, just like you normally would right here. So there's no like, there's no compatibility issue. They're just doing their own separate things, and you know, SVD produces its batch of images, and then Flux will take those images and do what it needs to do with them. And yeah, exactly. Yeah. Yep. Yeah, it's pretty cool. It's pretty, I think it's going to work out pretty great, because, yeah, again, it's just all you're doing is taking those images and passing them right back into Flux. So, and yeah, okay. So, self-sample Flux, right? We get our latents, we get our images, we stick them on the list, we keep going. On the next iteration of the loop, we have our images ready, so we can just pop that last frame off and then send that right back through SVD. And then at the end, we concatenate them all together like so and return them. So I think that's a good chunk of the work that needs to be done. Here I am saying it's going to take 100 hours, and, you know, maybe not. That last sampler that I made, though, definitely was like 100 hours. It's freaking crazy. Anyways, so let's give our comfy a refresh, and it should look, yeah, I imagine it should look a lot better. I mean, this is the reason why I don't use Stable Diffusion. Like, I made this well, hold on, I wanted to make the sampler and the model loader so that they're both compatible with using Stable Diffusion, because I know a lot of people like Stable Diffusion. But me personally, I've only used Stable Diffusion like a couple of times. I just installed Flux right away as soon as I got Comfy up and going, and it's just so much better that I didn't even really mess around with Stable Diffusion. Yeah. I mean, my thing is, well, yeah, you mean like make videos for people? Like, say, like promo videos or something? Like if some kind of, you know, Instagram person, or I don't know, some company or somebody needs a promo video, we could make promo videos for people. Yeah, that would be good. Because a lot of people, you know, even if they have the compute power, a lot of people are not going to want to install Comfy. I mean, even as simple as this process has been made, a lot of people still are not going to want to do this. So making videos for people is definitely one source of income I've considered for sure. And thumbnails too. Once I get my like customized instructions for the language model to where I can have it just produce really great thumbnails without, you know, very much work at all, then yeah, I definitely want to start making video thumbnails for people. And I want to get into making some actual, I guess we'll call them like short films as well, maybe music videos, things like that. Not for other artists, but like I want to make my own, not necessarily music videos, but short stories or something like that. We'll just say like maybe 4 or 5 minute long mini movies, basically like a mini, I guess you could call it like a mini TV show or something, but it wouldn't necessarily be part of a series. I don't really know of a good example right off the top of my head. I mean, I know of one example, but it's kind of dark, and I don't know if you guys want to go there. It's a little dark. There is, let's see here. Autodale. I caution, watch this at your own whatever, you know, this model citizen. This is being pretty. All of these are crazy, man. These are really, really crazy, especially this model citizen. It's well, both of these are pretty intense. Especially considering, I mean, this was made in 2020, and everything that's unfolded since 2020 with AI and surveillance and blah, blah, blah. It's like, whew, crazy watching something like this. But anyways, it's 5 minutes long, and it's like a little short story, and they did like hand animation for all of this stuff, you know, drawing all this stuff out. But I would like to produce, say, like 15 to 30 second or maybe longer scenes with the FVD, and then once I get the Stable Audio Diffusion going, you know, generate some sound effects and some background tracks with that, and then also have my own voice, you know, dubbed in as well, or whatever other kind of character voices I need dubbed in, and make like little short, you know, 5 minute something. That would be pretty cool. You could, you know, if you guys have been following the Door Brothers, that's kind of what they're doing. They're just generating like 5 second or shorter little sequences with the Hailuo AI or whatever that Hailuo. If you guys don't know, this thing is pretty cool. if I can remember how it's spelled. Hello I. Man, I totally forgot. Yeah, I can't remember right now, but ControlNet, etc. Yeah, exactly. Yeah, you can do so. Like on the initial image side of thing. Well, here's the thing. Here's what I really want. This is the next step. So first step is you have your initial image that you generate with Flux or whatever. That comes in, and let's just say it's this chick right here, right? So this is your initial image, and let's just say that the first sequence that you get out of this SVD run is going to be like her typing or something, maybe, just something simple, just a couple of seconds of movement. And then what I would like to do is have an option in here where you can kind of change up what's happening from sequence to sequence. So the first sequence would be her typing, and then the second sequence would be like she reaches over and grabs a cup of coffee and takes a sip or something, or the next sequence could be like a little cat jumps up in the window over here or something like that. You know what I'm saying? So it would be great to have right now, the first step of this process, the first step of building this thing is going to be to take this initial image, pass it through SVD, generate our sequence, and then in terms of extending that sequence, we would be taking the last frame from the sequence and passing it back through SVD, generating another sequence, and then going back through Flux to touch up the frames. But instead of just grabbing the last frame from the previous sequence, it would be nice to take that frame out and then send it back into Flux with different instructions, like with a different prompt. So instead of using this same prompt, we could go like the first prompt could be she's typing on her computer. The second prompt could be she's taking a sip of coffee or something like that. I mean, you could just do it independently. You could do that separately in different runs. You could do the first run where she's typing, and then do the second run where she's, what I'm saying? But it would be great if you could just have it produce the whole continuation from sequence to sequence, doing different activities. Right. Yeah. So you're kind of like, yeah, exactly. So you take the last frame from the first sequence and then you pass that back to Flux, but instead of giving it a prompt with her like typing on her computer, this time the prompt is going to be she takes a sip of coffee. And so you get that last frame from the first sequence as your starting point for Flux to work with, so it looks like it's kind of picking up right where that last frame left off. So yeah, that's the goal, but that's the next step. The first step is we just got to get this thing running and processing our frames, essentially like upscaling them or touching them up and making them better with Flux. And then once we get that, and once we get the continuation from sequence to sequence, like if you're walking down the street, you want the next frame in the second sequence, or the first frame in the second sequence, to be the last frame in the first sequence, so it looks like the person just continues walking, right? Yeah. There's a lot you can do. Everything is so like modularized and componentized. You can layer all these tools together. So yeah, once we get this done, building on top of it's going to be no problem. That's why I like software, man. I love software. One, because it's free, and like I don't come from money. So whenever I was thinking of like what can I do in life to build myself up, build up my skills, and I don't know, sell a product or like make a business or whatever. Well, I needed something free because I didn't have money to put into a business, right? So that's what drew me to software, was like like a synth for images. Yeah, I love that shit, man. It's so like tweakable and you know, modular and stuff. You can build small tools and then use them. You build a collection of small tools and then put them together into one big tool. You know what I'm saying? You can kind of like build. It's like Legos. Software is like Legos. So yeah, that's and it's free. So you know, it's a good place to start if you need something to do with your life. I think we should go ahead and give Comfy a restart and see what we got here. Let's see what we got. Let's try it out. Something's probably broken, but we'll see. Trying to see how much of a lag there is in my okay, so it's well, am I on live? Okay, let me it looks like I'm live. Hello. All right, so 38. Wow, it's like a 10-second delay. Okay, all right. Yeah, YouTube must be loaded down this evening, because YouTube is usually like maybe a 2 or 3 second delay at most. It's like 10 seconds right now. All right, so we got what do we got here? We got our things in here. Our params, our width, height, seed. I don't think anything's really changed here. We got our steps, guidance, Euler, DDIM uniform, denoise. So as of right now, everything that we used over here in terms of our max shift, base shift, denoise, that's, oh no, our denoise, we overwrote that. Yeah. So let's try to run this start to finish. Let's put our denoise on 1 right here and let's generate a new image. And so let's go with original. That's fine. And yeah, let's get rid of the script. And we can get rid of that. So we got the chick sitting at her computer, city skyline through the window. And so we're going to, I guess we could use the image. Let's just start from scratch. Let's go with an empty latent. So we're starting from scratch, 1920 by 1080. You know what? Instead of, let's just make it a little easier on our processor. Let's go, what's half of 1920? Let's just go 1280 by 720. I mean, this is still 720 video. It's not bad. That should be a little easier on the GPU. All right. So we're using Flux, we're using Euler DDIM uniform, guidance 4, steps 32, denoise 1, max shift, base shift. We're not adding params because this is going to get passed on to FVD, so we don't want any text in there. And we are just doing, you know what, let's do 2. Why not? Let's do seed 4 and seed 5. And so now we'll have 2 images to choose from there. And let's see what happens. All right. I think let's go for it. All right. Here we go. Ready? Break. You just stay there. We're not going anywhere. We will have to go out soon, though. Have to feed that doggo pretty soon. Loading up. Yeah, let's do this. Probably it's gonna break. Nothing ever works on the first time. Holy, I'm dying. All right. All right, you. I got 2 live viewers on the music. That's cool. I don't know who's watching the music stream, but 2 people are. It's not really a good stream right now, the music stream, but it's good for background music. I'm gonna add a better loop, and I'm gonna add you know, artist information, add an equalizer, all kinds of stuff in there. Make it a lot more visually appealing. Bro is blazing. No, it's just nicotine, bro. It's just nicotine. If I smoke weed while I'm writing code, it doesn't go too well. I mean, sometimes it can be fine. It really depends. All right, I like I kind of like this image better, but I like this chick better. What do you guys think? Vote. Which one do we want to go with? I wish, man. I'm in Florida. There's not, I mean, unless you get a med card, which I do want to do soon, but there's not really much available here. I got some stuff from the vape store the other day, and it pretty much is, I mean, I don't know how they're selling it legally, but it pretty much is weed. I don't know. Maybe it's some kind of loophole or whatever, but Image 2. Hi, check 1, 2, check 1, 2, 3. Hey, Terrence. Terry, do you want to go by Terry or Terrence? Yeah, I like the chick in the second one, but I like the first image better. The computer looks nicer, and it's got these like vertical lights over here. I kind of like that, and the keyboard is lit. Terry. All right, cool. What's up, Terry? Terry, did you vote? Which one do you want, Terry? Top or bottom? I need to figure out the poll situation so I can get a poll going, but I don't know how to make that stupid poll thing work. Terry says top. It looks like it looks like you've gotten outvoted, Baka. Myself and everyone else seems to want the first image. I do agree with you that the chick in the second image is sexier, but the first image just looks cooler. So we're gonna go with that, and we'll have many times of doing this. So let's just see. Here it goes. Okay, let's come on down to the bottom. Yeah, I kind of like glasses sometimes. I'm picky about the glasses too. I don't want her to look like too much of a hipster. The hipster glasses are okay if it's not too hipster, if it's not too, you know. Yeah, think with your big brain. Alright, well, so SVD is running. As you can probably see right here in the bottom. Is this text big enough? I don't know if I can make this text bigger. I mean, I can, but I don't want to mess with it while it's running. Let's just see. Sorry, I forget there's a mic right in front of my face. My bad. $82, $85. Terry, you were wanting to find out about text, right? You were messaging me on Patreon. Text and images. Is that what you were talking about with your cars? Sample Flux takes 2 positional images, arguments, but 3 were given. So here's where we got. We passed in too many arguments. Yep. So if you see this thing here and you click on show report, it's just the same thing that you see in your terminal. So I usually just look at the terminal or command prompt, whatever. Right, so our sample flux method here, we're passing in 2 things. Yeah, so we just got to pass in, we're only accepting 1 parameter in that method, but we need to obviously pass in these images. So yeah, I forgot about that part. SVD sequence images, we'll go ahead and take that. Let's see here. Let's copy that and sample flux. So we got those coming in, and right, our denoise is there, and then we have this latent batch here. That's the other thing I forgot to do. We don't want that latent batch. What we want is our denoise here, and we're gonna have, we'll just call it latent batch, that's fine. Latent batch. Right, because we're getting the SVD sequence, the sequence SVD images right here. This is the 24 frames of video that we generated, and it's already been decoded using the VAE, the SVD VAE. So we have these as images right here. And so we just need to take the Flux VAE, which we got in the parameters, and we need to re-encode them. So latent batch is going to be VAE dot encode. And if we look over at our latent chooser, we have something over here, so we can see how we did it right there. We have generate, and then we have load and encode, right? We just did VAE encode, yeah. Output image, all. Interesting. All through 3. Interesting. Why are we going through 3 there? Huh. Anyways, I'm going to copy that and see how it works, and if it doesn't work, we can print something out and see why not. Okay. So we'll paste that right there, and we'll just call it latent batch. Latent batch. And so output image, this is going to be the SVD, the sequence SVD images. I don't know why we're doing all through 3 there on the latent chooser. Why did we do that? I'm going to get rid of that. I'm just going to do the whole thing. Maybe because we only need the first 3 channels. I'm going to leave it. All right. Bro couldn't show MP4. I got the SVD group to work this morning. Video, I couldn't load my video to Patreon. It couldn't show You got the SVD group working, but it didn't show the MP4. Is that what you're saying? All right, so our denoise is there. It probably needs to be lower on the denoise, but I'm gonna leave it there for now. All right, so now we got rid of that error because we can accept 2 parameters now, and we're gonna use that as our latent batch, obviously, instead of the previous latent batch. Okay. All right. Well, let's do it again. Goodness. Yeah, okay. Alright, everything else should be fine, just double check. 32 for Euler. Really, maybe this guidance should be higher. Yeah, just let me know. I'm around. Denoise, right, cool, CFG, alright. Selected image 1. Oh, we need to make sure we select the right image too. I didn't even think about that. Okay, let's run it. That's the one thing about developing these nodes is you have to wait on the models to load up every time. It's kind of annoying, but you know, it is what it is. All right, so we should get the same output here. I should have gone with something more. I mean, this is just a chick sitting at her keyboard. There's really not going to be anything for SVD to do with that. It's going to be like a panning or a rotating shot, something like that. I should do somebody like walking down the street. We should change this probably. Let's just see what this does, and then we'll change the prompt. It should be somebody walking or doing something with motion, you know. Oh, I didn't put my seed string list in there anymore. Okay. Well, this is what we got. That's what we're gonna go with. And here we go. Here we go. All that icing and all that cake. So many steps. I should have went with fewer steps on the SVD part of things. I mean, really, now that we're using Flux to touch these images up, we don't really need to go so many steps on the SVD side of things. I mean, honestly, now that I'm thinking about it, yeah, let's do this part too. Now that I'm thinking about it, right? So here's what happens. We get we load up our SVD checkpoint right here, right? And out of that, it comes with its own VAE, and it comes with its own clip vision model, and it comes with its own little model patcher. And we pass those things in here into this self-encode method right here, which is right there. And this is putting out this is putting out the latent samples. So what I'm saying is what I'm saying is this latent samples right here, this is already all 24 frames. And then from that point on, when we pass this to the K sampler, this is just a normal K sampler. So I think we could actually even get rid of this part of it and just go straight to Flux, which means this process that's running right now, I think we could eliminate this from the whole thing, which would speed things up a lot. I think so anyways. We'll try it both ways. No, you wouldn't lose quality. You just, it's the same thing. Well, I don't know. We'll see. It depends on the, it's really the, it depends on the auto encoding. So like the VAE for SVD, if that part is, if Flux is able to encode and decode the latents that are produced by the Stable Diffusion VAE, which, I mean, it's just a tensor, so I mean, like, mathematically it will work, but I don't know if the like the decoding algorithm would produce like, I mean, you could lose quality, or you could get better quality, or it could just produce something just completely nonsensical and random. You know, who knows what it'll do. Mathematically and programmatically, it'll work. You can pass that tensor into the Flux decoder, and it will decode it. But what you get out as the image is, that's what I don't know yet. But if it is able to handle those latents, then we could just get rid of this whole loop right here. Which would be great, because this loop is just not necessary. Yeah, we just gotta try it. I mean, worst that can happen is we try it the other way and it doesn't work and we switch it back. It's just a couple lines of code to change. Never meant to make your daughter cry. Alright, we're almost there. Oh, you sit down. This boy's hungry. I'm gonna have to, next time I run this, I'm gonna go feed him while this is running. Do 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 do. Moment of truth. Here we go. Will it move on to the Flux stage? Decoding. That's the SVD VAE doing the decoding. And oh, model and image params at model key error model. It doesn't have a key. It doesn't have a model key. I'm pretty sure I put that on there, didn't I? In image params. Okay, well, let's print it out. Right, because what it's looking at here is on the sampler, the params, we did put model on there, and that's the FVD out params, and that's the FVD out params that we're returning, and that's gonna get passed over to here. Oh, we didn't, yeah, we put it on the list, and so we're returning the list. And did we take it out of the list? I'm sure we did, didn't we? Yeah, we took it out of the list right there. Selected image -1. Okay. So let's do this. Let's print out init image params and init image params. So we'll print that out right there. And what it was saying was that it doesn't have a model key. That's in our sample flux method. So when we're in the sample flux method here, we're trying to get model out of it. And that is what we're passing in, right? We got our init image params right there, and then that's our init image params right there. Let's go ahead and print, let's print both of these things right here. Let's say boom, do some new lines in here. And we want to print out first of all, we want to print out the FS params, and then we'll print the init image params. FS, save. All right, so we'll print those out so we can see what's going on there. And yeah, let's go ahead and run it again and print that out, and we can find out what's going on. Okay, here we go. Wait a minute. Why is this unimported image? That's supposed to be, that's why. Okay. Hold on. Stop this. Stop this madness. Lake Placid. No, like the one in the movie. 1280. 1920 by 720. Yeah, let's do this part 3. I remember the movies, man. Those were crazy. When I was a kid, man, that scared me. I was like, man, I don't want to go swimming in the lake no more. There's going to be a big-ass gator. Oh, no, Lake Placid, Florida? Nah, I haven't heard of it. I live in Pensacola, so I don't know how far it is. But I'm way up on the panhandle. I'm pretty much right next to Alabama. We got empty Layton, yeah, okay. Let's run that. And actually, yeah, we'll do that, that's fine. Seed 4. I was wondering why we got a different image last time. It's because I was on the wrong... I wasn't using my my same size latent. I'm sorry, Miss Jackson. Oh, look at this. She got FlowState radio on the screen. Did I forget to take that out? Interesting. All right. Cool, man. That's like the same chick as before. Pretty much. Nice. I like that. I'm going to save that, actually. Let's save that. Open that in a new tab. All right. Take that. Progress. Yeah. If it's down near Tampa or something like that, probably it's not great. That's where all the hurricanes go, man. I mean, the last hurricane that came through, we didn't even get a drop of rain. We never get hurricanes. I think the last hurricane we got in Pensacola was like 10 years ago or more, maybe. I know it was a long time ago. they all come right up on the inside, like if the panhandle or whatever they call it, the peninsula is right there, they all come up right into the Gulf, and then they swing back right across Tampa every single time. Tampa, Sarasota, St. Pete, that area, it's not a good place to live. You're going to be rebuilding all the time if you're living in there. Not that I want to jinx myself. Now that I said that, I'm probably going to get the next hurricane right through Pensacola, but you know, so far I'm keeping track, and so far all of the hurricanes seem to do kind of take that same route right across Tampa-ish. All right, I'm going to grab him a little scoop of food while this runs. I will be right back. Grab an energy drink. Yeah, I would, but I want to save them for right now. I could do a tea though. These things right here, so addictive and just as caffeinated as an energy drink. Ah, so good. I used to work at this place in Seattle that had this huge break room, snack room, whatever. And it was like walking into a little convenience store. They had these huge coolers with like stocked full of drinks and snacks and all kinds of stuff. And I would just they had these things here. And I would just drink like 15 of these a day. And that's how I got a kidney stone. All right, let's see what happened. Right, same error as before because we didn't change anything. Now we're just printing some stuff out so we can see where we went wrong. All right, so here's our params. Yeah, man, they were just there. They had like, you know, bags of Cheez-Its and bags of other kinds of like chips and stuff, different kinds of snacks, Fig Newtons. They had oatmeal that you can make some breakfast. Yeah, everything for free. It was pretty dope. That was definitely the best break room of any job I've ever had, for sure. Yeah, they spent a lot of money. They stocked that thing every day. Yeah, it was huge, huge break room. But it's probably cheaper than paying their employees more money. So it's kind of a good way to entice people to work for you without having to give them more money. Alright, so here's what we printed out. We printed out our FS params, which is a list of parameter objects, or dictionaries, whatever you want to call it. So in this case, there's only one dictionary in here, so we got a list with one dictionary in it. It's got all of our information about our initial image that we passed over to SVD. And it has... I guess we don't really need the prompt. We could leave the prompt out. Yeah, we could delete the prompt from that. We don't need to pass that along. This whole line right here for the prompt, we could get rid of that. And we don't need, we really don't need any of this stuff here. We could get rid of all of that. We just need, we don't even need the model type. We just need the seed. Add params, false, add prompt. We could get rid of all that. So I don't see the VAE on here, and I don't see the model on here, which makes sense. That's why we get this model, this error down here, this key error for model. It doesn't have model on there. And, well, why is that? On the unified sampler, we have our FVD params out, and when we go through, we get the FVD params back out of there, and there's 1, 2, 3, 4. Yeah, that fourth thing, if we look over, oh, let me look at Comfy. Okay. Why are we, well, we're returning, that's why, we're returning the wrong set of params. So we got 1, 2, 3, 4. I don't know why I ever even returned those params. Because I didn't ever use them, so why don't I just take this out? FVD params out. Nice. Ice cream. Sounds good. Coding full time. Well, he said BRB, so I don't know if he's here. Yeah. All right. All right. That's a boy. Yeah. Sit down. Sit. Sit. Stay put. I don't know what you're getting into. No. Alright, watch it. Alright, just wanted to close that door so he's not running all around the house. Okay. So now we should get what we want. Let's go back over to Comfy. Hit up our restart. Actually, let me cancel really quickly. Okay, cool. I just want to make sure I save that image. Cool, man. That's pretty cool. I got some ice cream too. I have a tub of ice cream that I once every month or two I'll eat a little bit out of it. Alright, did our settings? Yeah, so we got 1280, 720, empty latent. Alright, let's go with that again. Okay. Cool, man. Cool. All right. Send it on. Oh, I forgot I was going to change the prompt to somebody like walking down the street or whatever. I'll do that in just a sec. Yeah, I don't know how many of you are doing like for me, whenever I'm like working, writing code or something, I'll be listening to music, and most of the time I will use Lo-Fi Girl. I don't know if you guys have Lo-Fi Girl. Let's do this part 5. Yes. So most of the time I'll like listen to Lo-Fi Girl while I'm I usually like this one right here, the synthwave radio. It's pretty chill. But I am doing my own version of that here. Oh, jeez Louise. I was going to zoom in, but anyways. Right now, there's still 2 people watching this. Interesting. Right now, there is lo-fi beats to drink tea and code to. Yeah, exactly. So right now, it's just a pretty basic loop. If you... Let me make sure I mute that. So it's just like this super simple... Nice, Baka, yeah. So it's really nothing special, but I want to make the, like the chill out lounge. Yeah, I want to make some better loops here. That's part of, once I get the FVD going, I'm going to make some better loops for this, and I'm going to put like an equalizer, like how I have, like on the stream that we're watching right now, I have the equalizer at the bottom, so I'm going to have the EQ on this, and obviously artist information, album artwork, all that kind of stuff, and a more carefully curated selection of music. So if you guys want to listen to music like that, listen to the stream and let me know like what types of, because I'm not going to do, like this one's mostly kind of like chill hop kind of stuff on this, kind of R&B stuff and stuff like that. But I'm gonna do like other versions too, like synthwave and jazz, or I don't know, whatever. I'll do different genres. So I want to have like probably 6 or 7 of these streams going 24 hours a day. So let me know what type of music you guys want to hear on there, and what type of like background loops and stuff would be cool to look at, and I will make it. Alright, so let's see what happened here. Cloud rap, sure. I don't know what that is, but I'll do it. Old spacey slow hip hop, yeah, sounds good. I would like to have like at least 7 to 10 of those 24-hour streams going. It's just like a really, if you're doing YouTube, it's kind of like a no-brainer. If you can do that, like if you have the setup to be able to stream 24 hours a day, it seems like anyone who can do that should do that. Like there's those other ones that you see with the hamsters, the little hamsters spinning on the wheel, and it's just like playing like loud house music or something. Any kind of like 24-hour stream thing you can do, I would definitely recommend doing it. If you have like a computer that you can dedicate for that 24 hours. Because I mean, that's just like free revenue. I was looking at the, if you look at the Lo-Fi Girl channel, she's got like 6 or 7 of them going. I don't know if it's a she or a he or whatever. It says Lo-Fi Girl for the channel. Ibiza stuff, yeah, I'll do that too. But she's got like 15,000 people watching at any given moment. Synth pop, all right. Yeah, she's got 14,000 people watching this video right now. It's like crazy. That's like a money printer. It's like, it's a no-brainer. So, okay, where is this? Let's delete some stuff off of this object. Make this easier to look at. So what are all the things we don't need, right? First of all, del, we don't need model type. So that's going to be FVD out params at model type. Okay, and we're gonna need to delete a bunch of stuff off of here. So we got model type, we don't need. We'll keep the seed, we'll keep the height, we'll keep the width, the sampler, scheduler, steps, guidance, max shift, base shift. We don't need denoise. And we don't need add params. And we don't need add prompt. And we don't need the prompt itself. Okay, so we'll delete all of that stuff off of our copy. And we should be adding the model, the VAE, and the positive conditioning. Right, we should be adding the VAE, the model, and the positive conditioning. So before we ever return from here, let's just print it out and see what we got before we ever leave the sampler node. Let's print out both of these. Self dot pref params, and then we'll do whatever, we'll leave it, that's fine. And FVD params out. Save that. Back to the comfy. Love green tea. Alright, let's change up our prompt too. Let's actually do this a little differently. Let's go here and make this 1024. 1024. That's still pretty good quality. And let's change our prompt. Let's see, we have right now, we'll get rid of the text. And we'll keep that part right there. And yeah, part 6. It's going to be like part 150. We'll get as far as we can. We'll get at least to a good stopping point. We'll get this first run working to where it actually upscales the images in the video sequence with Flux, and then we might call it a night from there. But we'll at least get that far. And then we'll get right back to it tomorrow. All right, so we have, instead of a chick sitting at her computer, let's keep the beautiful cyberpunk woman, because why not? But instead of sitting at her computer writing code, let's say walks down a let's say walks down a sidewalk of a busy street at night. Grammar be damned. And we'll go ahead and go with extra crispy on this one. And yeah, looks good. How's that ice cream, Baka? Oh, and to answer your question, yeah, essentially I'm like, I would say, if somebody asks me, I would say my full-time job is YouTube, because obviously that's where I'm trying to get money from. But yeah, it's not going to be, eventually I will diversify my channel and do more engineering and physics related stuff. But for right now, I'm sticking to the comfy stuff just because it's like, it's a popular thing and people want to see it. And, you know, I like writing code and I like working with AI and different types of AI models and stuff. And it's, you know, it's something that people need and it's something that I'm good at. So while I'm building a core audience and, you know, gaining more subs and stuff like that, I want to try to stick to this one kind of thing. And eventually I want to do more projects, kind of like Mark Rober, his channel, how he does those like engineering projects. Once I actually get some ad revenue money coming in from YouTube that I can invest into doing engineering projects like that, that's kind of the goal. I like electronics engineering hobbies, like and especially integrating like AI and stuff with them. I have I have some of these little microprocessor type things that I could, you know, integrate some AI models into and maybe make like some AI controlled drones or something, you know. That's one idea I had, but I like robots and drones and stuff like that. So that's the future goals for the channel. I think this is a pretty good image. SVD should be able to generate some frames of her walking. So let's see what we got here. But more importantly, what's the what kind of ice cream you eating over there? I don't do ice cream very frequently, but when I do, I get the cookies and cream ice cream, vanilla with the Oreo, and then I put strawberry cheesecake. Sounds good too. Nice. And then I take I get a bunch of Reese's cups and Butterfingers that have been sitting in the freezer for a while, and I crunch all that up and throw it in the ice cream with the Oreos. Fire. Yeah, it should. You just got to keep working. I mean, it's a lot of work. And I'm also, you know, doing school right now. I'm going back for a physics degree, so I'm trying to stay on top of YouTube and school at the same time. And, you know, hopefully get to a point where I'm making a decent living off of at least enough to get by. Right now, I'm kind of burning through my savings while I'm getting the YouTube stuff going. So we'll see how it goes. Hopefully I get paid from YouTube before I burn through all of my savings. So it's a race to the clock, or racing the clock. Racing the bank account. Oh, we need to scroll down, way down. Okay, here we go. We got some, what do we get here? Oh, okay, right. So we have on here, all right. Pulled output tensor, interesting. Okay, positive conditioning, yep, okay. So we have that on that object, and we have it on that one. Interesting. I didn't realize I put that on there, but okay, so we have it on there now. Okay. Yeah, my life is in a perpetual state of burnout. Really. Okay, so, alright, sampling algorithm, right. That's probably because I called it sampler, not sampling algorithm. Right. Yes. The sampler and scheduler, that's what I called it, sampler and scheduler. So let's just scroll back down here and get rid of these print statements. Save that, back to our FVD sampler, and in our sample flux method, instead of calling that oh, no, that's not what I wanted. Okay, fine. Sampler and scheduler. Right, yeah. Nah, you would be surprised. Whenever I learned software myself. Like, I never went to school for it or anything. And it was in my like early mid 20s. And I would get home, like whatever day my weekend fell on. I was working at Best Buy at the time. And whatever my weekend days were, like if I got off on a Thursday and then I had like 2 days off or whatever, I would crush energy drinks and coffee, and I would just sit in my chair like I'm doing right now, and I would just sit in my chair for like literally like 48 hours straight, except to get up and pee. And that's how I learned how to write code. So I don't know if I can be burned out anymore. I've done legitimately 36, 48 hours straight of writing code many times. Maybe longer, but for sure I've done 36 to 48 hour code streaks without sleeping and without doing anything else, without any breaks, except just to get up and pee and get some food. All right, so we've named these correctly now. The thing that we were seeing over here was there was another key error on sampling algorithm, because I was looking on this dictionary here. I was looking for sampling algorithm, but it's actually called sampler and scheduler. That's what I called it anyways. So, run her again. Yep, we'll run her again. One little step at a time. That's how this goes. I'd get him to swap our places, running up that road. Alright, so hit it again. Yep. Let's do, you know what, I want a little bit of variety here. Let's go 4 and 5 on the seed. That way we'll get 2 to choose from. Part 756. Oh yeah, I mean, that's how software goes, man. You it depends on how experienced you are, I guess. A lot of people will build like a little piece at a time, little piece at a time, little piece at a time, testing each piece as they go. But, you know, they say, like, if you want to make God laugh, make a plan, right? Plans always fall apart. Plans always change. I like to live my life that way because I've had, you know, so many experiences where you make a comprehensive set of plans and then everything falls apart or things change last minute or whatever. And it's the same thing with code. So if you spend like so much time building little pieces here and there and testing as you go, and you're inevitably going to get to the end and have to change a lot of stuff that you did to begin with. So I prefer to just write like huge chunks of code, and then I just go into it knowing like there's going to be bugs, and I'll just walk through the bugs one at a time, and eventually it'll work. Alright, so now we have a little bit of variety here. What do we got? Ooh, I like this chick on the right. She got some weird, like, boots going on, but, I don't know. What do y'all think? I like her boots. They look like robot leg boots. She got, like, matching gloves, too. Interesting. Left or right? I kind of like the colors in the background on the left. I don't like this big bright red and yellow over here. But I'll go with whatever y'all guys want. Terry says left. Going once. Any other takers? Going twice. Jared says left. All right, we're all in agreement. Left it is. So we do have our model, and we do have our VAE, and we do have our positive conditioning. So should be good. Or at least we should get past the last bug, which is progress. As long as we get past the last bug, I'll take it as progress. Get him to swap our places. Yeah, I think, what times work for you guys? Do you guys, if you see on my ticker on the bottom of the screen there, I have a little section that says streaming most days around 6 p.m. I feel like I'm not going to put like a rigid schedule like Monday, Wednesday, Friday or whatever, but I feel like most of the time when I'm writing code, I'll just, stream. And, but I'll kind of tailor it to around whatever time you guys want, 5, 6, 7, maybe later, maybe earlier. I don't really have any time sensitive commitments. All of my classes are online, so, I can work on that stuff whenever I want, really. There's only one kind of, there's only one like real-time commitment that I need per week for one of my classes, but other than that, it's all asynchronous. Midnight for you? Okay, so you're on the East Coast, huh? I'm just barely in Central Time. I'm right over the line. Yeah, I like working at night. You work at home or? Okay, so we got past that one. We got another one here. Latent image, latent samples. That is in this node's custom sampler, and okay, there's a key error. Latent samples, batch samples. Yeah, cool. Sounds good, man. Later streams are good. Night owl, cool. Yeah, that works. And I might do probably multiple streams throughout the day. I might do one earlier and one later too. Unable to install via Comfy Manager. Has this been discussed already? Did you try the install via Git URL, or did you just search in the Comfy custom nodes manager? Because if you search through the custom nodes manager, you're not going to be able to find it. You got to do install via Git URL. And if that's not working, it's because you have a security setting that you got to change. You did try install via git link. If you tried it that way and it's not working, do you get if you look on your Comfy, let me see here, if you go into your install via git URL, what happens whenever you interesting, new version is not letting me, Has anybody else in the chat tried to do that since the new version? I haven't tried it. I have a second, I have a spare Comfy installation that I usually will try it in, but I just kind of assumed it would work this time. But let's see if anybody else in the chat has any feedback here, and if not, we'll check it out. Okay, yeah. Let me know what error you're getting. All right, yeah. Put it on Patreon. You can put it in the chat in there. There's a bug chat in there. One of the chats. There's an image chat, a bug chat, and then there's some other chat. But yeah, you can throw it in the bug chat over there. I'll check it out. New security settings, Jared says. I'm not familiar. I thought, I don't really pay attention to the updates too much, but I remember a few weeks ago whenever I updated Comfy, in the, if you look in this little box right here, it tells you what's in the new release or whatever. And I remember seeing right in here that on newer installations, that Comfy should automatically have the security set to weak, so you should be able to do that without changing the security settings, but they might have changed it again. I don't know. Okay, so our error so Baka, you said you're trying to make this AI thing work. What are you trying to do with AI? You're trying to do you mean art stuff, or you have other applications? Alright, so when we call sample flux, sequence flux latents, it's right here where we call sample flux. Sampler custom advanced sample. Command git failed due to exit code 128. Okay, I'll check it out. Okay. A little bit of everything. Sometimes incorporate AI in my music as a joke, which people seem to love. Nice. Cool, man. Something annoying that blocks. I'll check my config INI. Yeah. Nice. New AI image and video related stuff. Yeah. Yeah, I mean, AI is a hotbed right now, you know. There's a lot of people in a lot of different areas of life that want AI solutions, you know. It's big. So luckily it's a good place to be working, because a lot of people want it and a lot of people don't know how to do it. So there's plenty of opportunity. You got to find your niche. Training emerging models. Nice. Making LoRa's cool. Right, so when we call the sampler custom advanced sample method, inside of there it goes into this node's custom sampler, and it's the latent that we're passing into it, which is this latent batch right here. Too many indices for tensor of dimension 4. So it has a tensor of dimension 4. Normal minus. Interesting. Do you know SP? Do you know if you're what your security settings on? Do you know where the config INI is? I don't know your name, so I'm just calling you SP. Unless that's Sandro. Is this Sandro? It's set to weak. Okay, yeah, if it's set to weak, it should be good. Yeah, I'll look into that exit code 128. Terry, you got the new version, right? Baka, have you tried to get the new versions? So we have, right, when we call our sampler custom advance, it's the latent batch that we're passing in right there. Let's try this. Yeah, if anybody else got the new versions through Comfy Manager, let us know. I'll try it in my spare Comfy as well. I don't want to do it right now, but I will try it after this stream. Okay, so we'll go ahead and just do one, since we all settled on the left image anyways. Extra crispy. I'll try through CLI to see what happens. Yeah. Okay. Yeah, I was gonna say you can also just like git clone into that folder. Whatever, I'll just let this go. It's fine. Extra crispy and 1024 empty latent. All right, cool. I should have actually printed this out too so I can see exactly what it's looking at here, but we'll do that on the next run. Let's go ahead and put the print statement in here. And SP, is this Sandro? I can't click on your name right now in the chat, but I just want to know if that's who I'm thinking it is. Unified sampler decoding complete. Oh, it's already done. Wow, that was fast. Nope, SP also on your Patreon. Okay, gotcha. Progress. How long did that take? That was 24 seconds. How long did it take last time? Scrolling. 26 seconds? Okay, well, I guess that makes sense. Thought it was faster. Yeah, you can delete the old folder and then try to just git clone from start, or from, you know, fresh without that folder there. Just go into your custom nodes folder and just delete the FlowState nodes folder entirely, and then git clone on the new repo. I don't know the functionality in Comfy whenever you, like if you already have those custom nodes and then you go git install, like install through git URL again like that, if it just overwrites, or how it handles that. I would think that Comfy would be able to handle that, and but who knows? I'm not really sure. Yeah, maybe. If anybody else tries it, okay, cool, nice. Yeah, if anybody else had the old versions, Baka, if you still got the old versions and then you try to do the git clone, or try install via git URL in the Comfy manager, let us know how that goes. %. Shoot, I wish, man. Okay, so same error here. Too many indices for tensor of dimension 4. So I put the print statement in here. We'll restart and print it out so we can see exactly what we're looking at right here with this latent batch. Because this latent batch that we're passing into the sampler custom advance right here, the sample method of the sampler custom advance, we're passing in this latent batch right here. And whatever's happening inside this sample method on the sampler custom advanced is throwing up some error. So we're going to print out the thing that we're passing into it and see exactly what's going on there. Yes, I know. I do have this little bit of stuff that I got from the vape store, but I don't know if it's THCA or whatever, but it's pretty much, I mean, it's just like any other weed I've ever tried. So nice little loophole right now in Florida, at least until I get me a med card. But we're not about to do that on stream. Not on YouTube anyways. I do like the little cartridges. If I could find some of those, that would be great. Because then YouTube has no idea what I'm actually vaping. But I think I'm going to have to get a med card for that, because I don't really know where you would get that. Nice. Cool. Good to know, man. Yeah, man, I just moved from, well, not just. I was living in Seattle with, right, yeah. I was living in Seattle for like 7 years or so. It is awesome out there, man. It's like Starbucks. There's a freaking weed store on every corner. It's so great. Where are you at in Washington, Jared? I actually lived in Bellingham for about the first year and a half-ish or so that I was there, and then the rest of the time in Seattle, like North Lake area. And I worked downtown, and then I worked at University of Washington for a little while. Gig Harbor, cool. Yeah, I like it, man. It's a cool area. I like the mountains and the forests. It's a beautiful place. But it just sucks that the West Coast, man, you don't really get, unless you suit up with a wetsuit, you're not really going in the ocean. It's freaking freezing out there. So, and my grandma, she was having some issues, and so that's why I moved. That's one of the main reasons why I moved back here. Living out in Seattle, I was only able to like come back home to visit like once a year because it's expensive flights and all that stuff. Yeah, I like sailing. Sailing is fun, man. But I do want to swim sometimes too, though, you know. I like the beach. I like the warm beaches. Really, what I want to do is go to like Costa Rica or something like that, where you have it. The way I like describe Costa Rica, I've never been, but you know, from what I can tell of Costa Rica, it's kind of like the best of both worlds between, say, like Florida and Washington, because you have the mountains and you have the forests and the jungle and all that stuff that you get in Washington. Well, I mean, you don't get jungle in Washington, but you get nice forests. And then you have the beaches, and you know, because it's a tropical place as well. So I like kind of like the north part of South America, Costa Rica, Belize, something like that would be great. You get the mountains, you get the forest, you get the jungle, you can walk out in your yard and pick fruit, beautiful beaches. That would be the place to live. That's my ultimate goal. I know Costa Rica is pretty American friendly. There's a lot of people who go from America down to Costa Rica. So I think that's probably a good place to check out. Sydney, Australia. That's another place I want to check out too, man. Go out in the outback. I'm terrified of your spiders, but other than that, it sounds like a pretty cool place. Right. Okay, so what do we print? Let's see here. FVD, sampler, sampling, clip vision, auto encoding. Yep, too many indices. Isn't Costa Rica part of the US? Nope. Costa Rica, I mean, legally, like territorially speaking, I don't know if we like own part of it or something, maybe, but not geographically anyways. Right, yeah, I know you're CAD, man. CAD Castle. Norway, yeah, Norway would be cool. Beautiful place, man. And the women. I love Nordic women. All right. So we have this tensor here, dimension 4, and it says too many indices. Well, the thing that we have here, is this in a tuple, or what is this here? This is in a tuple, so we need to get it out of that tuple. Yep. We need to get it out of the tuple. So if we're looking right here at our latent batch, we need to get it out. Get out of there. Alright, so now what I'm going to do is just print the shape, so we don't have all that stuff in the command prompt. Alright, so if we take that out of the tuple, we should be able to pass that on to... So I just took this latent batch. It was returning in a tuple, so I just took it out. It's in the 0th place inside the tuple, so I just took it out, and now the thing that we're passing into here should just be a tensor, which I'm pretty sure... Sampler custom advanced. Actually, now that I'm thinking about it, it might want... Yeah, because it's looking at the latent on samples, so it actually probably should be in a dictionary with the key samples. So let's go ahead and do that. So let's put this in a dictionary, and we'll give it the key samples. Yeah. Oh, I guess my earbud died. But is it a chiller tensor or a tensor tensor? I don't know if I know the difference. Chiller tensor? I don't think I've ever heard of chiller tensor or tensor tensor. Oh, I see. I get you. Wordplay. Well, oh man, OBS is annoying. OBS takes over my headphones sometimes and it just won't let go. Alright, hopefully it's a chiller tensor. Hopefully it'll chill out and do what I need it to do. No, I have a roommate. He's chill. He's gone a lot of the time for work. And when he is here, we pretty much just do our own thing. Sometimes we'll see each other in the kitchen and say hey, but most of the time we're just kind of like in our own worlds. Yeah, OBS is very nice, but sometimes it is very annoying. Yeah, for sure. I like it better than other options, that's for sure. Especially ones that you gotta pay for. I like OBS is free. I really like free stuff, especially in the software world. Flux Pool ID? No, I don't think I've heard of it. What's that? Pool ID, Flux Pool ID. Oh man, I'm gonna have to hit the head soon. Caffeine gets to me, man. I gotta go frequently whenever I'm drinking caffeine. Oh, is that all I got? Oh, I was about to say, I thought I had another little chunk in here. I'm gonna have to hit the little vape shop. One image training is how I could explain it best. One image training, huh? Sounds interesting. Oh, I'll have to check it out. Let me, I gotta run to the bathroom real quick. Poll ID is overpowered. I'll be right back, y'all. What flavor vape do you like? I like, right now I have this Cloud Nerds strawberry grape. I like the grape apple, and the strawberry grape's pretty good too. Sometimes I like the iced flavors, but I've been doing a lot of that recently, so I switched back to the regular. Strawberry mango I didn't really care for that much. This other one here, this watermelon berry, it's pretty good. Cloud Nerds in general is what I usually get. Has no attribute shape. Ah, okay. No attribute shape. Well, why is that? It's a dictionary object, huh? Oh, I'm stupid. Of course it is, because I just put it in a dictionary. Yeah, it's a dictionary because I just put it in one. Of course. Well, that was a waste of a run. All right, so at samples dot shape. Okay, goodness. My bad. That one was totally my bad. Apple Grape by Cloud Nerds. Yeah, they're pretty awesome. $8? Holy, $8 is great. They're like $20 at the vape shop, or maybe more. It might be like 25 or something. Okay, what are you complaining? Oh, unmatched F string. Yep, you're right. When you're right, you're right. Cannot mix up our quotations like that. Yeah, that grape apple is pretty dope, man. The strawberry grape's pretty good too, or apple grape, whatever. The strawberry grape is good, and I like some of their. Okay, signing off. Great fun. Hey, take it easy, Terry. We'll catch you next time. I'll be here tomorrow if you are. Did I hit Q? Q. I'll be back. Yeah, the Cloud Nerds is really good, man. I get, I don't know, I haven't really tried many other brands. Every time I go to the vape shop, they're like, try this one. I'm like, nope, I know this one's good. I'm sticking with this. I don't want to waste 20 or whatever dollars on a bottle of stuff, because I've tried some of, like, I was at work one time and I ran out and I didn't have my refill with me, and I asked somebody who he had like a sour apple or some kind of, no, it was like grape something, and I was like, okay, well, it should be pretty similar. It tasted so terrible, and then I had to just chunk that coil because it that flavor was just in there, and so yeah, I'm like, no, I'm sticking with what I got. I know it's good. I'm sticking with it. Get him to swap. 4-hour stream is insane. Yeah, it goes by pretty quickly. I've seen some people who stream like crazy. I mean, some people will do like all day streams. I don't know if you ever heard of Big Tech, but he streams like a lot. Dream making, that's a new name. You talking about the FVD dream making? The other nodes are released if you want to use those. I pushed the updates earlier today, so you can get those now. The FVD is technically in there, and it's called FVD, but it's really just SVD. But you can still use it. Yeah. It's a gamble, man. Yeah, Dream, they're up there. You can get the new ones. It just doesn't have, like I said, it has FVD in there, and it's called FVD, but it's really just a packaged SVD. But it's still nice. I mean, normally with SVD, you have to have like 4 or 5 different nodes, and this just makes it into one. So you got that at least. And then as soon as the real FVD will be done, I don't know, probably by the end of tomorrow, maybe the next day. Because I'm going to work on it pretty much nonstop until it's done. I got some class things I got to make sure I don't get behind on. But my classes, one of my classes this semester is, or it's like, we have like sessions. We have, in the semester, we have session A and session B, so I'm only taking 2 classes at a time, but I still get to be considered full-time because it's like 2 classes in session A and 2 classes in session B. So that's nice. But this session, this is the B session, and whoa, that's a long error stack right there. But this session, I got one class, mathematical methods, is kind of I'm sure it'll be kind of intense. It's not anything I haven't done before, but it's like an advanced math class. And then there's this like research class that I'm taking, but it's like, it's not really that intense. It's more like it's kind of exploratory. So it's mostly just labs and a little bit of reading and a couple of presentations throughout the class. But there's not really any like problem sets or anything to do in that class, so it's pretty chill. But as long as I don't get behind on that stuff, working on these nodes and working on YouTube, this is what I'm doing full time. So FVD will be done real soon. All right, so let's see what we got here. Okay, let's go a little bit further up the stack here and see what is related to my node. Okay, so we have this right here where I call self sample. Okay, looks good. And then down into here, sampler custom advanced, where I call that. And then the rest of this is inside there. So it goes through there. It looks like it's generating some noise, or is it not? Line 145 and forward, not enough values to impact. Expected 4, got 3. On the X shape, it's so is my tensor not 4-dimensional? I thought it was. Didn't we print the shape? We got, oh, it's not. Yeah, here it is. It's a 3D tensor for sure. Okay, so we're missing, we got to unsqueeze it. it took out the, so this 128, that's the 1024 divided by 8, because our image is 1024 by 1024. And anything that's processing the latent version of your image, it it scales the dimensions down by 8. So that's why you got 128 here. And 16 is the number of channels. So we need another dimension in here, and that's because the way I SVD right here, SVD, yeah, this thing right here is returning a 3-dimensional tensor, and we need it to be a 4-dimensional tensor. So basically all we got to do is come right onto this, and if we type unsqueeze, gotta unsqueeze it in the 0th dimension, and that should work. So it looks like it got pretty much all the way through the Flux sampler until it hit that little thing. So we'll give this a go. Hopefully it'll get all the way through this time. Yeah, looks pretty good. We shall see. Okay. Cue it up. Cue it up. Okay. Let's do it. Part 23. All right, let's see what's going on in here. So this is a 1024 by 1024, and it looks like it's taking about roughly 25-ish seconds, probably. This is the initial image for 32 steps, 23 seconds. So you got to think, when we're doing the video, let's say if we're doing a sequence of 24 frames, we're going to be passing 24 of those into Flux, and so that's going to be 24 times 23 seconds, however long that is, 400 and something, 500 and something seconds for a 2-second video clip. So it's going to take some time, but the end result will be much better quality than SVD. So that is what I want. I want really good quality videos. I don't want all the blurring and the artifacts and all that stuff. I want something you can actually use in a video, you know? That Hailuo AI or whatever, I cannot remember the name of it, but it's also pretty good. Oh, I forgot I gotta progress this image. Yeah, I should just turn that to pass through. Let me just put that on pass through so I don't have to do that. But let's see here. Door Brothers. I don't know if you guys have checked out the Door Brothers. I'm sure you've seen their videos. If you haven't seen their videos, this is awesome. But this model that they're using here now who's blazed? Pizza and ice cream. Sounds pretty fire though, I'm not gonna lie. I was looking for they tagged Jordan Peterson, Elon Musk. This video is pretty funny. All of their stuff is really good. But I was looking for, there it is, Hailuo AI. This thing right here. Oh, it looks like they redid their website. Yeah, looks like they've upgraded their website. But yeah, this thing is pretty nice. Let's just see what we got. Elon Musk accepting a Grammy. I guess it's the seashell. Oh, you gotta sign in. Alright, sure, I'll do it. Sure. There we go. Trial plan. Well, that's stupid. Alright. Get your Grammy, Elon. Let's see what it does. Yeah, up until a couple of weeks ago, their website was like all Chinese. And there wasn't even a login. You just literally, you just had this little field right here. You just come to the website and type it in and hit generate, and it just generated. There was no sign up or anything. And you had to translate the page to English because it was all Chinese. What do we got here? Sounds like we're still doing something. Okay. So far, so good. 116, we got the right dimensions there. That's good. Okay. Now it's... Oh, okay. Let's see what happened. Okay, well, she's just standing there. Huh, okay. Interesting. Well, oh, decoding batch is just one frame. Why we got one frame? Did we only pass one frame in? I bet that still is just passing in that one frame. Okay, init frame, decode batch, SVD latents, sample flux. In the sample flux method, SVD sequence. Did we just pass in one frame? Huh. Alright, well, let's print some stuff out and see what we got here. Print. SVD latent. Right, yes. As a matter of fact, I'm just going to print this whole dictionary. Latent batch. Let's print that. And then let's print... I guess we could print the decoded as well. Latent batch, and then we're going to go sequence SVD images, and I suppose first of all, if that's 0 samples, well, let's just print that and see what happens. And let's also print right here the sequence SVD images dot shape. Okay. Because on our OK video card to run with this, I mean, in my case, I'm using Flux in F4, and if you pay attention to my VRAM, it's kind of hidden behind the equalizer there a little bit, but where's that EQ at? Waveform. Let me turn that off for a sec. If you pay attention to my VRAM meter over here, hey, what's up, Baka? Usually my VRAM does not get over like 60-70%, and that's like on pretty large images. So you're really just doing image. You're really just doing Flux image generation with 24 images. So whatever you're used to running with, if you usually use Flux and whatever batch size you're used to doing with that, it's going to be the same performance, because you're just doing a batch of 24 really is all that's going on. But I don't know all the makes and models of GPUs, but I would say anything that has 12 gigs. If you got 12 gigs of VRAM or more, you should be doing okay. NF4 on a 2070 with 8 gigs of VRAM. Yeah, I mean, what size batches are you doing? Fast on the 4090, you have to maybe not, I don't know, I'm not really sure what that means. Is that like a Flux related thing, the fast thing? I like fast. Single image, 3 mins. Oof. Single image, you mean like what? 1920 by 1080? Flux related on startup. Send me a link, SP. I'll check into that, because if I can make it faster, that'd be great. What size images you doing there, Anthony? Eight steps. .1024 by 1024 with 8 steps, 3 minutes. Well, SVD or FVD, any kind of video generation is going to be a little, it takes time. It's got to do all the calculations. There's no way to speed it up. So, unfortunately, if you're doing 3 minutes on a 1024 by 1024, you can pretty much just extrapolate that out linearly. So, if you wanted to make a 2-second video that is 1024 by 1024, it would be 3 minutes times, however many frames you're doing. So, if you're generating 24 frames, then that would be 3 minutes times 24 frames. So it'd take about an hour just to get a 2-second video at 1024 by 1024. SP on startup, run, open. Maybe. I haven't looked at the batch file in a while. Let's see. All the way up here. Let me close this stuff up here. Oh yeah, it's down here. NVIDIA GPU batch, Windows standalone, S. It says add fast, like right here, like that. NF4. Try, hey Anthony, try this real quick. Go to Elia. Man, come on now. Should be in my search history here. Comfy Ilias Fiel. This guy right here, Ilias Fiel. Have you tried this one? All right, SP. Yeah, I'll save that in there, and then whenever I restart Comfy here in just a sec, it should take effect. Yeah, Anthony, let me know if you've tried this, because this is the one that I'm using specifically. And it typically only runs at about 10 to 12 gigs of VRAM. As long as your VRAM isn't filling up, you should be able to get through the steps pretty quickly. The problem is whenever your VRAM fills up, then it's got to process what it can and then take stuff out and put stuff back in, and it's just like it makes the whole process take a lot longer because it's got to do a bunch of matrix multiplications and it can't do them all at once. It's much more efficient to be able to just do the whole matrix operation at once, rather than having to break it up into parts. That's where all the overhead comes in. Flux 1 Dev BNB NF4 V2 safe tensors. Is that it? Your head's in the way. My head's in the way. Wait a minute. Oh yeah, shoot, sorry, my bad. My head is in the way. Yep. $14 seconds to 10 seconds. Wow, nice. I can run it, takes longer, but quality is better. Okay. Anthony, have you tried what SP was just suggesting for me to do on the with the fast in your batch file? You said it only works on FP8. Alright, I think I usually just have it set on default. I'll have to check and see what weight type I'm using. But if it's the same quality and faster, I mean, 14 seconds to 10 seconds, that's a pretty good speed up. Fast is only for the 4090. Oh, okay, I see what you're saying. Gotcha. Yeah, I can't wait until they release all the Blackwell stuff, and then the 4090s, the cost on the 4090s comes down, because I want to put like 3 or 4 4090s in this machine. At least 3. But they're still like $1,500 a pop right now, so. All right, so what do we got over here? Okay, yeah, I put the print statements in there. We're just getting a batch of 1 right here, so that's why we only have. That's why our girl's not moving, because it's just 1 frame. Smaller sizes and upscale later. Yeah. Okay, cool. Well, let me see here. I'm gonna restart now. I put my print statements in there, and we're gonna restart here and see if there's a difference. It was about 23 seconds on the last run to generate that image. We'll see if that fast thing helps out. And let's see here on the weight types. We have you said FP8, E4, FN. Okay, so it should be on that one. Let's give it a go. I don't know what default is. I usually leave it on default. I figured that's probably FP16, maybe. I'm not 100% sure. 37 with 12 VRAM would, yeah, I mean, if you can find a good deal on a 3070, anything with 12 or greater on the VRAM, I would try to go greater if you can, but if you can get a decent like RTX model with 12 gigs, that should do pretty good for you. It just has to be able to load the whole model up into VRAM at once. Whenever it has to split the model up into sections, that's what takes so long. Because you can do really big matrix operations on the GPU as long as you can get the whole thing in RAM at once. 4070, yeah, I think 4070 is a pretty good price. I haven't checked in a while, but oh yeah. 16 gig 4060 Ti, that sounds pretty good too. Yeah, if you can find a good deal on something like that. Yeah, I would say I would prefer 16 to be safe. 12 is cutting it close, because usually, like I said, the NF4 model takes up around 12 gigs or so on my system, but then like you're going to be running other things, like your displays are going to take up some of your VRAM and stuff like that, so it's cutting it a little close at 12. 16 is a little more comfortable. Yeah, that would be dope. I would love to have 4 4060s would be great. More would be better, of course. Yeah, obviously. I was thinking 16 VRAM too, yeah. Yeah, anything you can find a good deal on that has 16 gigs of VRAM or more should be a big speed up. Interesting, yeah. All right, let's see what we got here. I think I haven't changed anything as far as the code goes. I just have the print statements in here, so we're still just going to get 1 frame, but at least we can see what we're printing out here and see where the see where our 1 frame is coming from. Even have a 1070 with 8 running, another instance of Forge for SDXL running on the same computer. Yeah, SDXL is, I don't know exactly the size, but I know it's a good bit smaller. And SDXL is not terrible quality. I mean, I haven't messed around with it a whole lot, but I've gotten some good results out of SDXL. Yeah, how far we've come. Yep. In another like month, Flux will be like old news. Okay, so this says SVD latent is samples, dictionary with samples, tensor, and I should have printed the shape, but whatever, here we are. And then we have SVD images, and we did print the shape there, so that's a batch of 24 right there, so that's good. Okay, and then somehow when we get into here, we only got a batch of 1. Let's see what's going on right there. So we printed the shape of this, and this is a batch of 24 right here. SVD images, sequence SVD images, sequence SVD images. So that's what we're passing in. So it should be a batch of 24 going in to sample flux. So if we look in sample flux, this right here should be a batch of 24. I wonder if this VAE encode thing right here is just returning a tensor. I thought it was a tensor and a tuple, but I guess we'll check it out here. Let's say VAE encoded equals that thing. And we'll say right here, VAE encoded, and in between this, we will put a print statement. How about that? SDXL, SDXL then with 2 image, XDXL then image 2 image with Flux, yeah. Yep, that's actually another thing that I'm thinking about doing, because after I get done with this SVD thing, I want to get onto some more control net stuff, and specifically pose, like character posing in images and in videos and stuff. And I want to, as far as I know, Flux doesn't have anything for pose, or maybe it does, I'm not 100% sure, but if I have to, it'll be kind of like the reverse of this pipeline. For this pipeline that we're doing right now, we're kind of starting with Flux and then going to SVD and then back through Flux. With the pose thing, I was thinking I might have to start with SDXL to do the pose, the character posing, and then go to Flux after that. So that might be an option as well. Okay, so we're going to print our VAE encoded. VAE encoded. All right, let's print that thing out. And let's actually print right here. Let's say VAE encoded dot shape. Let's see what that gets us. As a matter of fact, let's do it on separate lines. If I can spell. Oh, I didn't even check the generation time with that fast parameter. Let's see what it got us. Oh, come on now. FVD, keep going. Oh, I'm still printing out that stuff too. Alright, so this was, that says 26. Interesting. Well, we'll try it again. Okay, same old, same old. Let's hit it. Waiting for control net to work for Forge and Flux. Should be coming out anytime now. I mean, there's control nets for Flux, but I don't know about Forge. I haven't messed with Forge. I lost my waveform. I want to get my waveform back. If only I could be running up that hill. Right. Yeah. I haven't messed with Forge or 1111, but I feel like it's all pretty much the same thing. It's just an interface for working with these models, so you don't. Are you asking me, SP, or are you asking Anthony? To be honest, I have no clue. I know on my system, Torch is up to date, but I'm using the portable version of Comfy. Torch Vision and Torch Audio need to be on 2.4. I see what you're saying. I think because Comfy has its own internal Python, right? So it's got its own Torch installation as far as I'm aware. I haven't looked into that too much, but that was like my intuition about how it should be. So like the Torch that's installed on my system is not the same Torch that Comfy's using, as far as I'm aware. Torch Vision and Torch Audio. Is that something you can check in the manager, or is it on a config file somewhere? Because that is one thing I've been wondering about. Probably something I should have looked into sooner, but I just haven't gotten around to it. I don't see code. Interesting what you're working under the hood and see how it's all made. Yeah, that's how a lot of people are, man. You just they see the code and it just kind of like their eyes glaze over. It's not for everyone, man. We all gotta have a specialty, and code is definitely not most people's specialty. It took me a long time to really get into it. Math and code both. It's like I used to be like that, where I just look at it and I'm like, ugh, what am I looking at? Well, you know, years and years and years and years, and then you eventually get to a point where you're like, okay, I see what's going on here. If only I could. Yeah, any questions you have anytime, man, Anthony, just let us know. We'll one of us in here will be able to figure out what you got going on. Should be able to anyways. Yeah, that's what I figure. I figure most people probably won't know like what's going on with the code, but at least like if you're seeing the parts of like, you know, how the VAE and the different samples, and as they're moving around, you know, each data object moving around from node to node, it'll give you a little bit better of an idea of what's actually going on. Even if you don't understand it fully, it's still helpful to know that context. Plus, it's just like, you know, cool to like chat with people who are into the same stuff and all that good stuff. So whenever we print out the VAE encoded shape, that is a batch of 24 right there. right there. We got a batch of 24. Okay. And then when we print out that, it's a batch of 1. Okay, so what's happening in between there and there? So when we print out this VAE encoded shape, right? VAE encoded shape, let's just make sure. VAE encoded shape, that is a batch of 24. Okay. And then down here, we get a batch of 1. Okay, so this is a batch of 24. So with me using this 0 right here, I'm selecting the first image out of that batch, which I thought it was in a tuple, so I guess it's not. So that's why I thought I was selecting the whole sequence, but I'm actually just selecting the first frame of the sequence, in which case I don't need this unsqueeze method either. I can just do it just like that. So now we should get 24, we should get a batch of 24 images to pass into our Flux sampler now. Yep, should be good to go. So now we should actually get a Flux video sequence. If I can find the right tab here and restart Comfy, we should actually get our first Flux video sequence. Pip show torch. Yeah, but the thing is, the thing with doing that pip show torch is, hold on, let me let this load up. So if you look in Comfy in that batch file that we were looking at earlier on the startup, where is it at? Right here. You can see what it's calling. It's calling this Python embedded. So Comfy actually has, like, whenever I go to my command prompt right here and I say like Python -- version, oh, like that. That is the Python installation that's on my system. But Comfy is using a different version of Python. It's not using the Python that's installed on my system. It's using, if you look in this Python embedded folder right here, which is right here, that's its own version, that's its own little, that's all of Python right there. That's a full complete Python installation right here inside this folder. So it's using its own Python. So that's what I'm saying is I don't really know how to update its little internal version of Python. I was just hoping that it happened whenever I update Comfy. Maybe they just update, you know, Python and Torch and all that stuff in the Comfy updates. I definitely could be wrong about that. It looks like they're using 3.11 right here, whereas mine is 3.12. So, and then as far as the Torch goes, I don't know how to even check what version of Torch they're using really. I mean, I guess there's probably a way, because in these files, we are importing Torch here, so I should be able to there's probably a property on this Torch object that shows what version it is, but I haven't looked into that. But yeah, that's one thing I've been wondering about is, like, how do I update, like, their internal version of Python, and how do I update their Torch libraries and stuff? But I haven't had time to really get into that too much. The latest Comfy includes Torch 2.4. Okay, good. Yeah, I updated Comfy like maybe a week ago. I should probably do that more frequently, but it should be on. I don't know if there's a way to check. There's probably a config file somewhere or something that I can check, but yeah. Okay, we got a Comfy UI log here. What's under update? Current requirements. Okay. fix torch, folder paths, Python dependencies, stable batch, update comfy UI. Alright, quit pushing on me. Python PyTorch, it says 240. You said it has to be on what now? Torch Vision need to be on 240. Yeah, looking at this, it looks like it is on 240. It looks like it anyways. Let's see here. What do we get? Did I run this? Oh, I guess not. Alright. Run it. .240, yeah. It looks like it's good. I should, I'll update Comfy too after the stream. I guess I could do it right now. It's probably wouldn't take very long. Be running up that hill, running up that building. All right, can you stop? All right, go on. No, 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 go on. Get out of here. Here we go. Oh, it won't be the last time, but it'll be the last time before we actually get our Flux sequence. But there will be many more times. Be running up that building. Yeah, let's see some vids. After reading what others are saying about fast, they're seeing improvements even on a 3070. Huh, that sounds good. Yeah, I might not have it configured properly or something. So I'll have to look into it, but yeah, obviously I definitely would, especially for generating video, would be great if I could speed it up. Especially for like 1080 video. Because generating a single frame with NF4 right now, I'm about like 40 or so seconds, 50 seconds to generate a 1920 by 1080 image. Oh shit. Be running up that hill. Yeah, I'll check it out. Yeah. Yeah, I'm sure my comfy setup as far as the like speed could for sure be optimized a bit. That's one thing I haven't looked too much into. I've just been kind of depending on my GPU to do all the work for me. Here we go. Encoding. Let me be real, you don't gotta worry about speed. I mean, you know, when it comes to generating video, like here's the test right here. We got a batch of 24 that's about to go through Flux. Let's see how long that takes. Oh my god, is my nose bleeding? hope my nose is not about to bleed. Yep. I don't know how that happened. I have to excuse my disgusting nose, but occasionally it just starts bleeding out of nowhere. Well, are we hung up? What's going on over here? My VRAM is maxed out, so it looks like it's got to clear something out before it can move on to the next step, which is something we'll have to optimize for. Maybe the comfy lords are to blame. Yeah, even just one more 4090 would make this a lot faster. All right. Goodness, this is taking a while. Nice. My little cousin just messaging me. It looks like he is getting that he's getting that that cloud nerds that you were talking about earlier. I think that was Bird talking about that, right? Jesus, my nose. This is ridiculous. Not trying to be gross on stream, but when it's bleeding, it's bleeding. Not much I can do about that. Well, is it gonna load? You can use software for fixed noise called NVIDIA Voice RTX. Fixed noise? What do you mean fixed noise? Oh yeah, I got you. Yeah, I mean, I have there's like settings on the Logitech thing. I wasn't expecting to run the AC on this stream, or else I would have set it up to get rid of the background noise a little bit more. But I don't want to mess with it right now while I'm streaming, because it, you know, knowing my luck, it's gonna mess something up, and then you won't be able to hear me at all. Yeah, I have this this little NVIDIA broadcast software. I'm sure there's a feature in there for it, and there's also in the Logitech for the mic itself, it has its own software, and then there's plugins in OBS too. So I'll just have to set something up. I wasn't planning to run the AC. It was getting a little chilly earlier, and then it just like warmed up out of nowhere. I don't know why my VRAM is so clogged up. I gotta unload this SVD model. It does not want to move though. Well, I suppose, let's see here. Let's look at this while we're waiting on it. You fix soon load GGUF. Yeah, that's one thing I gotta do as well. I want to get as much done as I can on this FVD node, but yeah, I'll look into that as well. Not tonight, probably tomorrow I'll look into it. It sounds like it shouldn't be too hard to add into it, but I'll take a look tomorrow and see. Sure, man, no problem. So the question here is, can we I guess, can we unload? What we really need to do is unload SVD before we load Flux. I was hoping that Comfy would, well, I mean, this is all in the same node though. That's probably why it's not unloading. I think as far as like going from node to node, like once it gets past the sampler node, it unloads Flux, and then whenever you get onto the next node, you can load up SVD. But here we're doing SVD and Flux in the same node, so I wonder if there's a way to force it to unload SVD before running Flux, because right here at this point we're moving on to Flux and we're done with SVD, at least for this iteration. VRAM debug might help. Yeah. Yeah, I wish I had a way of knowing what is currently loaded into memory. But I would think that if I'm press thumb up to allow more people to come. Oh, right. Yeah. Definitely give it a like. Every like helps, man. Every like helps. So yeah, I need to see if there is a way to, I think my computer, hopefully my computer is not about to crash. Everything's still looking good for you guys on the stream. Is it lagging, or I might have to force quit Comfy? YouTube says it's an excellent connection, but it also looked like it was lagging for a sec there. Okay, cool. Yes, the bird is the word, that's for sure, man. Okay. I think we might force quit Comfy and try. Oh, no. Alright, what is this GPU doing? Before we quit, let's just take a look at what do we got going on over here. Yeah, Adobe stock. I didn't even think about that. That's a good idea. $94, $96. I really wish I could figure out how to get my system to fall back, my GPU to fall back to system memory, because we got a whole lot of system RAM that's not being used. That would be really nice. So we got a little dip here. Makes me wonder. I wonder if it's the batch size being 24. I mean, I've done batches of 24 and more. Yeah, you could overclock, but that's not really going to help a lot in this situation. Yeah. Yeah, that's the problem with setting things to run overnight. You're not watching the process, so it's harder to find bugs, yeah. Okay, so let us do a force restart on Comfy. And let's try a different approach. Let's say well, ideally, I wish it would just use my system RAM. I wish it would pull my memory so it could just use up some of my system RAM. That would be great. If the GPU could just use system RAM. I know there's a way to do it, I just don't. There's a sysmem fallback policy in the NVIDIA control panel, but it doesn't seem to work, at least with Comfy anyways. Well, before we do that, I don't even have Schnell, so let's try a different approach here. So at this point, we have right here we go through SVD. And what have you graduated? What is your background as a programmer or learned from chat? I just learned just building projects over the years, man. I started out way back in the day writing PHP, just like getting into some like HTML and PHP. I mean, if you remember back into the MySpace days, with MySpace, they would let you write a little bit of HTML to like change, like customize your page, which is still such a really cool feature. I hate that that's not around these days, but anyways, that's where I started getting into it. Like learning HTML and stuff, and then I got more into web stuff and PHP and server-side stuff, and then JavaScript and all that stuff, and just grew from there. And as far as AI and machine learning, I learned that before I even went to college at all. There's a course on Coursera. Well, there's probably more than one, I'm sure, but Andrew Ng, he is the guy who founded Coursera, and he's a really, really good teacher. And for me, even without having any kind of experience, Yeah, PHP. I remember the PHP days vividly. I do like PHP. I mean, these days I like, obviously, like I would write anything that I used to do with PHP would be done now with like Node.js or Python maybe. Usually when I'm writing server-side stuff, it's Node.js. It's really fast. I really like Node.js is a really fast language. But yeah, I just, I built projects and projects and projects and projects, all kinds of different areas, and that's how I learned to code. And then the machine learning stuff I learned from Andrew Ong on Coursera. Perl, very nice, yeah. I haven't done a lot of Perl. I messed around with it a little bit just to see, and Fortran and some of those other kind of more niche languages. But yeah, these days I'm pretty much Python, Node.js, and then for embedded stuff like microcontrollers, you use some C++, maybe a little bit of C here and there, and other than that, it's just like a whole mess of different config files, that are written in their own different scripting languages like Nginx or, whatever, just whatever kind of system services you're using and configuring. But I really like Python. I love Python, man. It's a great language, especially for scientific computing. Huge community support for scientific computing packages. I mean, NumPy alone is great. NumPy and Matplotlib, fantastic. So anyways, we have, yeah, you can't go wrong with Python. No, I don't think we've stretched the limit in AI. Not at all. There's plenty more to come. Yeah, you're good. I understand you. Yeah, C++ is great. Or just C. C is great. But it is hard. It's much harder. It's a lot, yeah, debugging is a nightmare. Overall, just all around harder to write that code. All the typing and everything. Yeah, you're good. I understand what you guys are, I understand what you're saying. It's pretty good English. What's your native language, Six? So right here on, this is where we produce our latents. We do our SVD VAD code. Oh, Bulgarian and Greek, cool. Really cool, man. Those are two languages I have not even tried. I've practiced Arabic and Chinese and Russian a good bit. Not so much recently, but I can get around in those languages. Someday I'll be as patient as Steve Gibson and be able to write everything in assembly. Oh yeah, that would be great. There's some projects I want to do around that. There's a course, Jared. If you like that stuff at the processor level, there's a course called NAND to Tetris. I think it's also on Coursera, but I think they also have a standalone website, so you don't need to access it through Coursera. You can just go to their. If you just Google NAND to Tetris, let's see here. I'll look it up right now. This thing is great. Yeah, right here. These guys, a couple of Israeli guys out of I can't remember what university they're at, but these guys, Noam and Shimon, really smart guys. This course right here, you literally go from NAND gates up to a full 16-bit PC, and you're writing it in VHDL. It's really, really cool. So if you want to learn how to actually build like Harvard architecture or some kind of CPU architecture, RISC architecture, or I don't know if you've heard of any of those. If you want to learn how to build a processor from scratch, from logic gates, this course is really, really great for that. So after doing this course, I really want to put it into practice. And there's several things you can find, but one that I found that is really good is this guy, Ben Eater. He has a whole YouTube series on this, and he builds processors. Like, he built a whole CPU. I think his are 8-bit, but it's kind of hard to do on a bunch of breadboards. So even just building an 8-bit processor on breadboard is freaking awesome. But he has a whole AI chip makers, ASICs. Yep. I mean, that's what Tesla already does. I don't know if you know, but several years ago, they converted from, I don't know if it's an entire conversion. They might still use NVIDIA to some degree, but I know largely they're using a custom ASIC that they made in-house. So whatever neural network model that Tesla uses for their full self-driving, they actually converted the hardware to an ASIC. So that's why they're able to do stuff so fast. But yeah, more and more ASICs will start popping up. Yep. The thing with ASICs is right now the models are so flexible, they're changing all the time, and the problem with an ASIC is once you build it, you can't change it. I mean, to some degree there's a little bit of flexibility in there in certain cases, but once you etch the thing in silicon, it's etched in silicon. So if you can get to a model that is not going to change for a while, and then you turn that into an ASIC, then you got something good. The Bulgarian language is the language from which Russian meaning has come out. They've stolen it from us. The Cyrillic alphabet is our project. Wow, really? I did not know that. But that makes sense. But I figure in terms of languages, just learning, like if I learn Russian and I learn Arabic and I learn Chinese and I learn Spanish, then that's enough. Like, because if you think about like Arabic compared to like Hindi or some of these other Middle Eastern languages, there's a lot of overlap in the languages. Like, I don't know how much overlap there is between Arabic and Hindi, but there's a good bit of overlap. So if I learn Arabic, I should be able to, and most people in that area, whether they have like some native dialect, they'll still learn Arabic as well. Like most people, like if you go to school in I don't know, like this is probably wrong, but just as an example off the top of my head, if you go to school in Afghanistan, you might have like a local Afghani dialect, but you still learn standard Arabic as well in school. And so if I learn Arabic, that allows me to communicate with a whole lot of people. And same thing with Chinese. There's like, obviously Taiwanese is different, but there's so much overlap that if I learn Chinese, then I should be able to communicate with Taiwanese people and other people in the surrounding area really well. I mean, not perfectly, but it's and the same idea with Russian. If I learn Russian, then there's a lot of, Eastern European countries that have very similar dialects, so I should be able to communicate with a wide range of people just by learning Russian. So that's the idea with languages for me. I want to learn kind of like the core, although maybe I should learn Bulgarian instead if that's like the core, really. Yeah, a lot of Latin languages as well. Yeah. Generic transformer ASIC, exactly. Yeah, it wouldn't have the sliding window and everything. Yeah, it would be cool to do. I definitely want to do something like that. But first of all, I just want to build like a basic, like 8-bit or 16-bit, processor. I think that would be a really cool experience. Exactly, you would need a different ASIC for each architecture. That's the problem. If we can just get to one architecture that does it all, like Transformers is pretty close. Transformers can do a lot of stuff. If we can just perfect Transformers to where, and I actually heard recently that LSTMs are making a comeback. I didn't look too much into it, but I saw some headline somewhere that some research group has gotten some LSTM performance up to the level of Transformers in some regard. That's just like a very quick glance at a headline, so I'm not sure. But anyways, if we could get either LSTMs or if we could get Transformers to a point where they just like handle any kind of data you throw at it, vision or text or any kind of sequential data, or if we can get one architecture that can do like everything, then we can start scaling up these ASICs like a mother. And I'm on the side of AI will never be sentient. I don't believe that sentience can be accomplished through intelligence mechanisms. But it will be definitely convincing enough to seem sentient for sure. And I feel like that is just around the corner. Probably within the next 5 to 10 years, we'll be passing legislation to, protect the robots. You can't do a hate speech against a robot because it has feelings, that kind of stuff. I feel like that's less than 10 years away for sure. Maybe less than 5. But it's gonna get wild over the next 5 to 10. Going back to the Door Brothers, they just had a video a couple of weeks ago where they kind of addressed that, the idea of like an AI robot running for office, and it's wild to think about. Once they have these humanoid-like robots that look, with the skin texture and everything, just looks like a real human, you can't really even tell the difference, and the reasoning and the logic and the speaking ability is convincing enough that it's like you think it's a real sentient being in there, and it's gonna run for office. And it's gonna be wild, dude. That's so crazy. And people will vote for it. People will be like, oh yeah, that thing is smart, it knows what to do. Yeah. I mean, these days I'm like, what even is real? I don't even know what real is these days, but yeah, I know what you mean. Yeah, it's going to be hard. It's going to be very difficult to tell the difference between machine and man very soon. Oh, right. So here's what we wanted to try. Right, so we have a batch of 24. Let's just break it up and try to do it into frame by frame. Right, so let's go frame by frame. Sample flux. Here's what we'll do. I don't know if this is going to work, but we're going to try it. Let's see here. For frame in SCQ. Yeah, okay. Oh, yeah, that's not what I wanted. Sequence. SVD images. And we want to say sequence flux latence sequence flux images equals list. And let's see here. So for frame in, right. So we'll just pass in the frame by frame. How about that? Yep, I totally agree. I think we're already to that point, really. Nobody really cares what's real. And there's good and bad that comes along with that. Probably to some extent we shouldn't care so much about what's real and what's not in some areas, but I think it's probably still important in certain areas. Yeah. We're going to be living that ghost in the shell life pretty soon. I'm going to get those big eyes, robot eyes, so I can see thermal and night vision and infrared and all that stuff. That was a pretty good movie. Not into anime. I never did watch the anime stuff. I'm pretty sure Ghost in the Shell is an anime, right? But the what's her name? God, I cannot remember her name. She's like one of my favorites too. She's awesome. Not Jennifer Lawrence. I always want to say Jennifer Lawrence, but it's the other sexy blonde chick. Anyways, yeah, the Ghost in the Shell chick. It's a pretty good movie. Alright, so once we do that, we go frame by frame, we stick them in this list, and then we still have old people and whatnot angry at AI. Tons of people I've seen that don't like a person at a personal level because Did you see that Transcendence movie with Johnny Depp? Yeah. That Johnny Depp, Morgan Freeman, where he's dying of cancer and then they transfer his consciousness into a machine, and then he essentially takes over the world, basically. Those anti-AI groups, rebellions or whatever, it's pretty good. I like it. It's a pretty good premise. And but there's these anti-AI groups in there, and they're blowing up AI labs and stuff like that, like terrorist acts or whatever, because they don't want AI emerging and taking over the world. And it's going to be like that. Yeah, I feel like there's going to be attacks like that on labs. I'm sure there probably already are, we just don't hear about them. At least cyber attacks and stuff like that, trying to hack into AI labs and shut them down or whatever. Yeah, exactly. They're like, oh, I hate AI. Yeah. I mean, I get the sentiment. People don't understand it, and, it's powerful and you don't understand it. Obviously, you're going to not like it. But it's a messy subject, man. It's a messy subject. I mean, I'm not like an anti-tech person, obviously. I'm sitting here doing AI stuff right now. I understand the dangers, and I understand that that people in power, especially like retarded politicians, they're going to use this stuff in any way they can. And right, yeah, Dune universe, yeah. I don't know too much about the lore in Dune, the backstory, but I think it's I do like the movies. The movies are pretty freaking dope. I can't wait for the new movie. That's gonna be awesome. I think there's a lot of parallels between Dune and our actual reality in terms of like religious themes and stuff like that, cultivating prophecies and stuff like that. Very similar to our actual world. Yeah. Yep. Pretty much AI racism, I guess, if you want to call it that. But yeah, people are like that with anything. They just want to find something to hate, and they don't understand it. It's stupid, but I understand. I get where they're coming from, even though they're wrong. But then you have other people on the other side who are like, oh yeah, AI is... we're going to create a real sentient AI, and it's going to be a real person. And I don't agree with that side either. I'm like, yeah, you guys seem just as stupid to me as the people who are like, oh, I hate AI. Like, it's just like, you know, it's the same thing as politics, right? You got the conservatives, you got the like Republicans, and you got the Democrats, whatever. They're just two sides of the same thing. It's like, you guys are both... I don't want to offend anybody, I guess, on stream, but the Republicans and the Democrats both have the wrong idea. The reality is somewhere in the middle, and you guys are just kind of fighting over meaningless nothingness. It's the same thing with the AI thing. Yeah, there's going to be a transition of some sorts, that's for sure. Hopefully it's a good one. At this point, I have no idea how it's going to go. It could go incredibly badly, or it can go incredibly awesomely. Olivia Sarika sounds very familiar. Yeah, interesting. I haven't gotten any of those types of comments yet in my videos, although my videos are not like that crazy, so I don't know. But Olivia Sarikas, yeah, it sounds very familiar, but I don't doubt it. Yeah, people are gonna do that. It's a crazy world out there. Yeah, I'm pretty sure I've seen some of his videos, because don't hate me, Jared. Yeah, I mean, AI for me is the same thing as any other technology. It's like, it's got good uses, and I mean, if you want to look at it like, oh, AI is evil, or technology is evil, or whatever, I mean, if you want to think about it, money is evil, music is evil. There's really nothing in this world that is completely good. You gotta just take the good with the bad and do the best you can with what you got. And it's like it's all we can do. So AI is here. It's not going anywhere. You can either use it and learn it and try to be someone who uses it for a good purpose, or you can just sit back and complain and let all the tyrants use it for tyrannical purposes. Like, I don't know. Right, yeah. Yep. People are just, people need something to hate. Right, yeah. It's just a new tool. So let's go frame by frame. Let's stick each frame in a list, and then at the end we'll stick it all together. See if that can get me through without clogging up my memory. Sequence flux latents, and copy this one, and we'll go, this one should be images. Alright, let's see if that'll work. While I'm thinking about it, you know what? Let's try getting rid of this SVD loop. If we take all of this right here, we got to do the sample flux regardless. But what if we don't decode? What if we don't even do this SVD loop right here? What if we copy this and bring it right here? And then let's take this whole thing right here and comment all of that out. Oh, we got to do the positive and negative conditioning. I wonder if we even need the negative conditioning. Huh, that's interesting. It's very interesting. Well, let's try it and see what happens. We have our latent frames right here, so let's do that. Latent frames. And then we have our, let's see here. Sample flux. Right. Okay, that should be fine. Let's try that. Sample flux with our latent frames. Oh, the positive and negative conditioning. I don't know if we even need that, to be honest. I mean, I think the important part is this latent frames here. Whenever we do this, whenever we use the clip vision to encode the latent frames based on the initial frame, I feel like my intuition about this is that these latent frames that we get out of this clip vision thing here, my intuition about this is like this is my batch of 24 frames, latent frames, that need to be sampled in order to produce something that can resemble an image. But does it really even need to be? Well, there's the patched model. Model patcher, min CFG. Well, let's just try it and see what happens. Worst case, it doesn't work. Let's put an S on that, and let's put an S on that, and save that. And we might, the conditioning is going to be different, so we wouldn't even be able to pass that in. I I mean, we can pass it in, but we wouldn't be able to use it. So let's see what happens if we try it like that. That would be great, because I would love to just get that SVD loop out entirely. All right, here we go. This does not look that great. I wonder what they've done. It looks weird. I mean, it kind of vaguely looks like Elon, but this is definitely not as good as it was like a couple weeks ago whenever I tried this thing. I did this exact same prompt, Elon Musk accepts a Grammy, and it was way better. It still wasn't perfect, but he just looks weird. What the hell? Yeah, it's freaking weird, dude. Let's see if we can find I might still have that video I did of the last one. Yeah, I'm sure I have it somewhere. Let's see. Oh, Grammy. Yeah, here we go. Oh, yeah, here we go. This one is much better. I mean, he still kind of looks a little weird, but not perfect, but it looks much better. It's crazy. The prompt was just Elon Musk accepts a Grammy. And it's like, it's a pretty good thing whenever it works. I don't know if they've made some updates or something, but that looks super weird. Anyways, we restarted here, right? Pretty sure we restarted. Oh my God. I'm gonna have to get some food soon, y'all. Well, I appreciate the compliment. I hope to be better than Elon Musk, because I mean, he's not a dummy for sure, but in my opinion, he's not nearly as smart as people make him out to be. Which, you know, whatever. He's successful. He's doing his thing. But people think of him as like freaking Tony Stark. Like, he is not Tony Stark. All right, well, let's see if it'll do something here. Nope. What do we got here? Has no shape. Okay. Yep. It has no shape. All right. Well, that's just fine. Crop encode VAE encode crop pixels. What are you doing? Are you cropping my? Don't be cropping my VAE encode. That's on 147. VAE crop pixels, pixel samples, and it's trying to go pixel shape. It's a dictionary object because I need to pass it in as the sample. So latent frames is right there, and yeah, latent batch 0 samples. Okay. Latent batch 0 samples. This seems to think it's a dictionary object, huh? Yeah, Tony Stark. Maybe. I feel like he would have his own thing. Maybe he wouldn't have bought Twitter. He would probably have something like that, though. Yeah, my thing on Elon, I'm pretty sure Elon is the same as any other billionaire. It's just a CIA asset, basically. I don't think any of these major companies get started out of somebody's garage like they like to. Oh, we built Microsoft out of my garage. Yeah, right, bro. Yeah, Tony Stark would have done it right. VA encode crop pixels. Dictionary object has no shape. So that means what I'm passing into this VA encode line right here is a dictionary object, which means that's on 147, which is listen right here, which is what we're passing in there. So it should be, okay, I probably need to actually comment. Well, maybe not. Let's just leave that there. And then we can say right here, let's get that samples. And CBWeeby. Let's just CBWeeby here. They did build Microsoft out of a garage. They did build Microsoft out of a garage with test tubes and jets. Right, yeah, exactly. Exactly, yeah. A really badass garage. That's the kind of garage I want. Speaking of Tony Stark, I made this, I started naming things, like, you know how he has like Jarvis and Friday and whatever the other ones are named. The like AI models that are like acronym based names. I made a, I don't know if you guys are using OpenWebUI or Olama or whatever, anything on your machines locally, but I'm using OpenWebUI, and I don't want to open it up right now because I'm already struggling on my VRAM, but I created this like model file for one of my models that instructs it to come up with like those kind of acronym names, and it actually does really well whenever I'm using like Llama 3 or whatever. I don't know if I have any names. Do I have? Yeah, no, it's not running right now. Okay, what do we got here? 128 channels. Yeah, that's not right. 24, 128. Okay, yeah. If only I could. I use LM Studio a lot now. I haven't heard of that one. I'll check it out. POE. Nice. Yeah, I tried doing it to where like I gave one of the models like all these facts and like, you know, instructions on how to like act like Donald Trump, and then I gave another one the same kind of instructions about how to act like Joe Biden and tried to get them to fight each other. It didn't work out too well. I need something like truly, truly uncensored for that. Even the like uncensored language models really aren't that uncensored. David O. I've heard of Eric Hartford. Did I print the shape of this? Okay. Okay, so let's see what we have here. We have latent frames. Let's just print out. First of all, let me get rid of these print statements. And then we'll get, say, that one. Paste that right there. And we'll call it latent frames. Latent frames. And then we'll do another one. Whatever, that's fine. Latent shape. Now latent frames, I think, has sample flux, latent frames. Alright, let's see here. Module, autoencoder, self-encoder, Z from X. First stage model encode pixels in. VAE encode on 147. Okay, so that's cool. It's getting through there. And right here we have latent frames at samples. If we look at the code here, what we had was SVD latents is latent batch at 0 samples. So I wonder if, I thought that's how that should be, at 0 samples. And maybe we'll try that as well right here at 0 at samples, and then dot shape. Give that one a go. Alright, man, take it easy. I was actually just about to say the same thing. It's getting, I think it's about food time for me. But have a good night. We'll see you, I'll be here tomorrow if you're here. Take care, man. Oh man, I keep doing that. I'm so bad about using quotes in the wrong places. I hate using double quotes. I almost always use single quotes. So then I end up using 2 sets of single quotes when I can't do it. I can't do it. All right, restart. Cue it up. Cue it up. Okay. Let's do this. So I don't know if you caught what I was doing, but what I'm trying to do is just eliminate the SVD step and go straight to Flux. Well, you use like the clip vision to generate the batch of frames, and then instead of denoising with SVD, okay, hold on. Okay, so here we go. Dictionary, SVD latent, dictionary with samples, that makes sense. And then it's all zeros. Interesting. Okay, that's weird. And then we got right here, latent frames at 0, SVD, latent shape. So we said this one that says SVD latent, that is a dictionary with samples. Alright. So this one is the dictionary with samples, so I can't have this 0 index thing in here. And if we look at it again, it looks like it's all zeros. Huh. In which case, we might need this positive conditioning right here. There might be a way we can convert that, but let's just try it. Let's see what happens here. Let me go ahead and comment this out so it's not printing out that whole thing. Rest assured, Baco, we will get there eventually. Maybe not tonight. But we will get there. One way or another. This will happen. It won't take months, that's for sure. I don't want to jinx it, but no, it'll be on the order of days. Okay, come on now, what are you doing here? Oh, do I still have a 0 in there? Where did that happen? 196? I thought I took that out. 196, oh. Wait a minute. Did I not just restart Comfy? Latent frame 0, sample shape. Did I not save this? Save latent frames. I know this one needs to be changed, but latent frames, samples. I must not have restarted Comfy. I thought I did. Or maybe I didn't save the file. Boop, 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 doop, 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 doop. These coding updates go hard. A stream where you even create nodes could be cool. What do you mean? Not sure I'm following there, Baka. Node creation streams. I mean, that's kind of what this is. It's just a long one. Okay. Latent frames. That samples doesn't have to be double quotes too. English is asks me to say the coding upstream. The coding update stream goes hard. Mean to say the coding update stream goes hard. I have to think about that for a sec. Samples doesn't have to be double quotes too. You're talking about right here? Nah, it doesn't matter. The only reason it has to be double quotes right here is because it's inside of a string. So I have a single quote string, and inside of it I have this in quotes. And if I used single quotes right here, then essentially it would just end the string right here. So it would be like this part would be a string, and then this part would be a string, but then the middle would be like nothing. So yeah, if I have an opening single quote and a closing single quote, and if I use single quotes anywhere in between there, it's going to think I'm trying to close off the string. Yeah, so that's why it's got to be double there. Right, it said, oh, okay, I see, gotcha. 196, wait a minute, why is this still saying 196? Am I tripping? I gotta be tripping. SVD latent shape, SVD latent shape, that's this line right here, right? There's no zero here. I took the zero out. It's saying that I'm still trying to index with a zero there. Am I? Oh, God. Scroll down. I was like, no, it's not still doing. Okay. This is where we're at. All right, so SVD latent shape 24.4, 128, 128. Good. Okay, gotcha. And it says weights of size that expected input 24, 128, 0. Why is it expecting that? 128 channels instead. Interesting. 128, 24. They have 3 channels, got 128 instead. Okay. Interesting. Latent frames, encoded components. Okay. Expects 24 128 0 128. That's weird. Interesting. And on SVD latent shape, we got 24 4 128 128. No, I just have to think about how to gotta think about the right way to shape this this batch. On this latent chooser, we have right, so we have the batch size, 16 channels, and then height and width. So in this situation, we have the batch size is going to be the first dimension, and then the second one is the channels, and then we have height and width. And in ours, we have the batch size, we have the channels, and then we have height and width. So that's good. And that works for a Flux sampler. And so when we pass that in, oh, I bet it's the conditioning. Interesting. I wonder if we could pass that conditioning on through and try to use that. I would think that's not going to be compatible, but if it was, that would be pretty cool. What if we try that? Positive conditioning. And then we go right here. And we try that as well. We'll just comment that right there. Alright, can you chill, bro? Okay. Because the conditioning, so the conditioning is what, it's like the numerically encoded text prompt, essentially. And you have to be able to do operations with that tensor and your latent tensor. So they have to have shapes that match, or else it's not going to be, you're not going to be able to do the operations. And so I was passing in the SVD sequence latents, but I was still using the conditioning from that got passed over from Flux. So I guarantee they're not compatible shapes. So I'm wondering if I pass the SVD conditioning in, if that can be used. I'm gonna guess probably not, but it's worth a try. I'd like to see what happens. No, far from dead. Nope, just gonna take a little bit of experimental trial and error. This is like there's no set procedure for this. It's something you just kind of have to wade into and figure out how to make it work. But we will figure out. I know that it will work. I just got to figure out how to make it work. But I'm not saying that in the sense of like, oh, I'm confident that it will work. I'm saying it in the sense of like, theoretically, mathematically speaking, it will work. I know that for a fact. It's just a matter of figuring out the right way to pass things to one another, and so that the operations can be done. But the operations can be done if I figure out the right way to pass the stuff in. It'll work. SVD latent shape 24.4 128 128. Thank you. To have 3 channels, but got 128 and channels instead. Yeah, so it's getting 128. Expected input. Alright, let's go back to our print statements here. We got that flux latent in, SVD latent, flux latent in, flux latent in, latent shape, processing, torch, SVD latent shape, PAE encoded, goodness. If only I could be running up the hill. Be running up that building. Ew. I make a deal with God and get him to swap our places. Mm-hmm. 27:30. Alright, what do we got here? That's a tensor. And that is a list of tensors. Oh, that's interesting to see. That's really cool. Motion bucket ID, FPS, augmentation level, concat latent image. Ah, okay. That's really interesting to see. Okay. So we have this list, and in here we have a tensor and a dictionary, and the dictionary has a tensor, concat latent image. Ah, that's fancy. That is really interesting. Cool, cool, cool. Okay. So this first tensor here, this is conditioning. And then this tensor here, interesting. Concat latent image, interesting. Concat latent image, tensor. Let's see the shapes of these things. So let's see, to make sure that's at 0, should be 0, 0, 0, 0 should be this, and then 0, 1 at concat latent image. So let's try this. Yeah, it's gotta be. Just when I'm like, oh, I want to go get some food, then I see this and I'm like, oh, that's really interesting. I want to dive deeper into that. Let me see what that is. Alright, so 0, actually this one's going to be 0, 1. And then if I do another one of these, 0, 0, and then we'll just get rid of this part. And here I go with the single quotes again. Double quotes right there. Thank you. Alright, so we have that, and I'm just going to comment that one. Let's put a little thing here. 0, 0, and on this one, right here, dot shape. Shaper, and on this one, dot shape. Alright, so 0, 0 should be a tensor, and then 0, 0 or 0, 1 at concat latent image, that should be a tensor. So I should get shapes on both of those. Yeah, I know. I make a deal with God and get him to swap our places. Shit, bruh, shit. Yeah, tomorrow I'm going to shoot, I'm about to be man. I'm gonna do another little run or two just to kind of explore this a little further, and then I'm gonna go grab some food, and I got a tiny little friend waiting on me here. That's all it takes. I don't need much. Okay, so this one is 1-1-1024. Interesting. And this one is 1-4-128, 128. 1-4, 128, 128. Well, that's our latent size, and that's the right number of channels. Huh. Interesting. What is this 1-1-1024? Huh. 1-1-1024. I wonder if we look at the conditioning that we get from Flux. Let's call this Flux positive conditioning. And I think that should be a tensor as... No, that's not a tensor. That is a... It's back here in the history if we look at it. Let's scroll up a little faster here. Not that one. It's like right in here. I printed it out. It's very interesting seeing the data structures that they have for these different things. Because from the outside, looking at Comfy, you're like, okay, positive conditioning, negative conditioning. But those things, they're actually some kind of matrix. They're some kind of mathematical, like data structure. It's some kind of tensor or matrix or vector or something that holds some numbers basically, and seeing exactly how what the shape and size of them are, and it's really interesting, really insightful, or inciting. It gives me insights. Okay, here we are. So this is the Flux positive conditioning right here. So in the Flux positive conditioning, we have a tensor, or we have a tuple that holds a list, and it looks very similar to the SVD positive conditioning. We have this smaller tensor. We have a tuple with a list, and the first item in the list is this smaller tensor right here, and then we have a dictionary and a bigger tensor. So this looks very similar to the SVD positive conditioning we're looking at down there. Very similar. So I wonder if there is some way to do the operations without doing the SVD first. That's very interesting. Okay, so we have that right there, and let's look back at the okay, well, let me see the exact shape of these. So to see the shape, we need to look at, right, positive conditioning, 0, 0 again, so that should be that, 0, 0, and then 0, 1 at pulled output. So we got similar to this right here. If we copy both of those and paste that in, really we should call this SVD. We'll call this one Flux. 0, 0 on that is fine, and then 0, 1 here should be well, it should be this pulled output right there. So let's see what that looks like. Okay. That one is 1-1-10-24. Interesting. The other one was 1-1-10-24 also. Huh. That is very interesting. Okay. So I'm looking in the wrong place for this pulled output. Let's look at this a little more closely. Right, it's on. Okay, so we have 1, 2, 3, and then 1, and then 2, 3, and then there's the end of the tensor. Oh, okay. Is it 0, 0? Because that's 0, 0, 0, 0 is the tensor. 0, 1, 2, 3, 1, 2, 3. That closes off the tensor. So it should be 0, 0. That should be 0, 0, 0, and this should be 0, 1. And it does have pulled output right there. So 0, 0, and that should be 0, 1. Should be. There's nothing else at the end here. Tuple. Yeah. Oh, wait a minute. Should be a tuple. Huh, yeah. That's my face right now. 0, 0, and this should be 0, 1, huh? Okay. Well, let's try. Let's do it like this. Let's see here. It should be. Oh, am I? Okay. Adoy, I should be looking at flux positive conditioning. That's why. Okay. There we go. Yes, I know. All right, let's give that one a go. Give it a go there. Alright, I think this is gonna be the last one. I gotta get some food. And I should probably get a couple hours of sleep. this one run, see what she looks like, and probably call it a night. We were talking about shows earlier. Do you remember what shows we were talking about? Someone was saying there's a show to watch. I can't remember what it was. Fallout, yeah. Oh, the Penguin, yeah, that's what it was. And Last of Us, yeah. My cousin probably has both of those, I would imagine, on Plex. Alright, so SVD latent shape, yep. Pause conned, right. Okay, so here we go. 1, 256, 40, 96, and then the other one is 1 by 768. That's interesting. So it's not at all the same shape as the SVD one. So we are going to have to... We got 1, 1, 10, 24 on that. And we have 1, 256, 40, 96 on that. So that's not going to work. And then we got 1, 768. And then that is 1, 4, 128, 128. Okay. So we're going to have to do the SVD step first. But that's not a big deal. So down in here, we're not going to be able to skip over this common K sampler step here. We're going to have to do that. On 4chan 8ly. So let's just go ahead and, well, we can leave that. That's fine. And we can get rid of that because we're not going to be able to do it right there. And we'll go back to this little method right here. See if we can't get this to go. So we're going to do our SVD step, and then we have this right here. Latent batch add samples, latent batch, and then this should be 7-hour stream. Yeah. I mean, I figure, you know, it's kind of a long stream, but at the same time, I would be sitting here doing this anyways for 7 hours, so why not have, you know, some company? And, yeah, so then we do our VAE decode. And, yeah. Okay, let's, right, we're going to do that where we do frame by frame and then stick them in there. Latent's torch cat, latent's a pin. Okay. Probably not going to run, but we'll try it. 7 hours, yep. Got 112 views, average view duration 28.5 minutes. So that gets us to, let me hit Q right here. Was that 112, 28.5? So that's 112 times 28.5 divide 60. About 53.2 watch hours. For sure, I sit here for long hours doing similar. Yep, exactly. Yeah, might as well have some company. Yep. Exactly. Yeah, we'll go soon. Yes, we're gonna go soon. You stay. Alright, so here goes the SVD step. Well, the other thing that I didn't even think about is tried the new CogX video wrapper and my GPU decided nope. Yep, the same thing here. I mean, mine actually worked whenever I did the CogX video wrapper, but it's just like it takes forever, and it's a really small video and it's decent quality, but I mean it's still a small resolution. So if you wanted to blow that up to like 1080 to play on a 1080, you know, in a 1080 video, you're gonna lose quality, obviously. And it's just like, you know, I don't know, all that wait time and overhead on the VRAM and stuff, it just doesn't seem worth it to produce such a small video. Like, if I get this FVD running and it takes a long time and it, you know, eats up a lot of VRAM, but it ends up producing good quality, you know, 720 or 1080p videos, that's a win. But I'm not really willing to do all the waiting if the output is just going to be like some really small video. It just doesn't make sense. I'll wait for good quality and high resolution, but the width on the cog, I mean the aspect ratio is locked on the CogX. Like, it only does that one size. Yeah, it's very specific on the size. If you try to do anything outside of that, it just won't work. And it's like, I don't want a video that's only 720 wide. And plus, it's like a new thing, and so there's not a lot of other stuff available in terms of, like, if you want to like mess around with IP adapters and control nets and other things, and, you know, whatever. It's just, in general, it's better to have something custom. You can, like, when I get this done, I was talking earlier about doing, if you're familiar with like Animate Diff, they have kind of this thing that they call, what do they call it, like prompt scheduling or something, where you can kind of like at different points in the video generation process, you can have like different prompts, so it kind of directs the video as it's being generated. So it doesn't work that great, but something like that built into this FVD is the goal. So, you know, you can do all kinds of things whenever it's custom, whenever you make it yourself, and then you know exactly how it works, and you're like, oh, I want to add this feature, so and now now that I've made this and it's running and it's doing, you know, the basic job, now when I want to add features, I know exactly how to do it. So yeah, Animate Diffs is not bad, but it's not, it's not really, it's not the greatest. It's not, I mean, it's probably, I would say I like it as much as I like SVD for different reasons. But neither of them are exactly what I want. All right, positive conditioning, sample flux, missing, required. Oh yeah, duh. So what did we print out here? Let's see here. So that's the, okay, interesting. 24, 1024, 1024, 3. That is the right shape. I'm pretty sure that's the right shape we want. If we look up here, we have SVD latent, samples, tensor, okay. And SVD latent, is that right there? Yeah, Kling looks pretty awesome. I haven't tried it out yet, but it does look really cool. Yeah, it would be nice if it was open source. You know, they'll do like their next version pretty soon, and then they'll probably release the old version for, I don't know, who knows, maybe. Hopefully. But also, who knows, it might be something that we wouldn't even be able to run on our machines. Kling, I mean, it might be too big for a consumer grade machine. They do have some really cool features though. Alright, so looking at SVD latent, we have that, which is a dictionary. Just to make sure, SVD latent here is a dictionary with samples and a tensor. And then SVD images, this is our tensor. It is in a tuple though. Oh no, that's just the size. I put that in parentheses. Okay, so it's not in a tuple. Okay. Torch size, right. 24, 1024, 1024, 3. So this should be the right shape we need. And then what happened down here, I don't think I passed in the right arguments. Yeah, okay. Cool. Alright, well that's cool. Let's see here. So we have that. I need to take that back out of here. We don't need this positive conditioning passed in. Yeah, okay, let's try it like that. Init image params, sequence SVD images, right? Yeah. I'm just gonna get rid of all these print statements right here. And this says positive conditioning. Right, that's fine. We can leave that like that. And then so we have the positive conditioning, and then we have our images here. We encode them like so. And then there's that latent batch. All right, so let's go ahead. Let's put one print statement right there. Let's say seek SVD images should be seek SVD images dot shape. Pretty sure that's a tensor, and then right after, let's put another one right there. And VAE encoded, and that's gonna be VAE encoded, and if I had to guess, it probably, no, okay, no it's not. I think we can check the shape right there. Alright, for real, this is the last one. For real, this is the last one. For real, this time. I make a deal with God, get him to swap our places. Okay. For real. Have you ever tried Comfy multi-GPU? I have RTX 3060 12 gig for Comfy. Also have a 1060 laying around. It doesn't hurt to try. I don't have another GPU laying around, or else I would try it, but it definitely doesn't hurt to try. I have a feeling it would probably work. That's just a guess, but I have a feeling it would probably help. Because these backend libraries, like that Torch uses, it's all reliant on the NVIDIA CUDA math libraries, and those I'm pretty sure are able to detect and use multiple GPUs. I'm pretty sure. So I think that should help out. I would definitely try it anyways. It would be really nice if we could just get comfy to use system RAM, because I got a lot of system RAM and it hardly ever gets used. It would be great if I could just load all of these tensors up into the system RAM, load the model up into the system RAM and everything, and then just have the GPU do the operations. I feel like that has to be possible. I like the way you ride with that booty on me. And get him to swap our places. 15, 28, 37. Well, I guess something it does. Sometimes it does that automatically. I see sometimes RAM getting filled up at least 50%. Yeah, it's weird. Sometimes I do see it using system RAM as well. Also, I can run Flux on 12 gig and don't think would be possible without RAM offloading. Yeah. On Dr. Pepper, I used to drink a lot of Dr. Pepper. That used to be my soda of choice. That or Mountain Dew. But I haven't drank soda at all. Well, I guess I have been drinking some cherry Pepsi recently, but other than that, I haven't drank soda at all in probably like a decade or more. I don't even know, really. Here's our auto encoding. Okay, so let's see here. But yeah, I used to on the way to school every morning. My dad would stop at this gas station and get some coffee. You don't like cherry Pepsi? And I love cherry Pepsi or cherry Coke with hot wings. I was ordering for a while. I was getting what's it called? Not DoorDash, but Uber Eats. Uber Eats was like giving me all these deals, like 40% off, 40% off, 50% off. And I was like, well, shit, if I do an order 50% off, that's like pretty much the same cost that like if I just cook it myself. So I might as well take advantage of that. So I was getting Uber Eats for a while there, and I was ordering Buffalo Wild Wings with like a bacon burger and just trying out all their different wings, and cherry Pepsi with wings or cherry Coke with wings. So good, so satisfying. All right, SVD images, Tensor. I do Sprite. I used to hate Dr. Pepper, but recently. Oh yeah, I was gonna say on the way to school every morning. Like in middle school and high school, my dad used to always stop at this gas station and get coffee in the morning, and he would always get me this whatever I wanted for breakfast, but it was usually like a big honey bun kind of thing, cinnamon bun type thing, and either Mr. Pibb or Dr. Pepper. That was like my breakfast for a long time during school, but probably wasn't a good move looking back on it. Tensor 24, yeah, okay, so that one looks good. And then this one is, we have 1024, 1024, 3. Ah, interesting. And this one is right, because I'm going frame by frame there, so we lost a dimension. Yeah, okay. So in theory, that looks like it should work. Sequence SVD images. This one is SVD images. What? SVD images. Oh, okay, so that's that one. Huh. Okay, well. This says SVD images is 24. All right, that's our batch. Yeah, okay, that's good. And then seek SVD images, right, okay, gotcha. Yeah, I like seek SVD images, 1024. So we gotta unsqueeze. We gotta unsqueeze that thing. We gotta unsqueeze that thing, man. Dot unsqueeze. Manager restart. Yeah, sparkling ice is alright. I like getting like LaCroix or some kind of sparkling water and mixing in like pre-workout or some kind of energy drink like that, energy caffeine kind of thing. It's kind of like your own energy drink thing. But really all of this stuff is poison. I usually am like crazy healthy. I've just been conserving my money lately. Trying to get this YouTube thing going, so I haven't been eating and working out and drinking water and stuff like I should. Usually I don't drink any soda. I don't do caffeine at all. Yeah, Yeah, usually I don't do soda, caffeine. I usually don't do the nicotine vape. I usually don't do anything at all. Just drink a lot of water, eat a lot of like organic beef, and work out like crazy. But I've lost a lot of weight. I'm a scrawny boy now. We'll get back there. I just got to get this YouTube thing going first, get the money going, and make sure I stay on top of classes. And once I get the YouTube monetized and have I don't feel so much pressure to grind so hard on this, then I'll get back into working out and treating my body like I should. One step at a time here, though. Yep, nice. 100 pounds, wow. Short, skinny, pale. Yeah, he was AI. Yeah. Yeah. Yeah, man. Gaining weight's hard. You gotta eat a lot. You gotta eat a lot. What you gonna say this time? What you gonna say this time? I should work out. Would like a consistent job first. Yeah, money is the priority. Cause working out, eating right, it all costs money. So you gotta get money first and then fitness after, or else you're just gonna spend all your time and money and efforts on your fitness, and then the money side is gonna slack. I've made that mistake for sure, focusing way too much on working out and fitness and all that good stuff, and then I'm like, damn, all this money I'm spending on food. It costs a lot of money to eat like you should eat whenever you're working out, but and it's worth it. But you got to get to a point where you have that kind of money first. Exactly. Yep. Yes, sir. Gonna get rich AF. And then I'm gonna eat all the steak. I'm gonna have steak every day, every meal. I'm gonna have steak every meal, for real. Very soon. Gotta get that YouTube money train going. Well, I guess, yeah. Freaking any steak is expensive these days. Freaking Walmart, like cheap. The cheapest of the cheap ground beef that they have at Walmart is like $6 a pound. It's crazy. Like 73% fat. I mean, 73, you know what I'm saying? Like the really fatty, low end ground beef. Like $6 a pound. It's crazy. Well, this is running, so that's cool. We're doing each frame here. It's taking about 23 seconds, as we would expect. Will it get through all of them and stick them together at the end? That is to be seen, but it's running, so that's cool. So to be clear, the SVD part's already done. It already generated the 24 frames, and now we're going through each of those 24 frames with Flux, and hopefully at the end of it will stick them all together and produce a video. So that's 1 2 3 4 5. Yeah, so this is frame number 6 and 7. No, you just chill out. You just sit down. This has nothing to do with you. I'll take you out in a minute. I know I said the last one was the last one, but now that this is actually running, if it If it doesn't successfully stitch them together after this, I'm gonna fix that real quick and then run it again, because it would be cool to see the output. I want to at least see this output before I call it a night. Even if it doesn't look great, still would just like to see it. Yeah, exactly. Except there's no mom here. It's just me fighting my own consciousness. One side of my brain is screaming, eat, get water, drink, eat. And the other side of my brain is like, no, I want to finish this. So far, very interesting. It's processing all the frames, so that's good. And the other thing is that our denoise... What up, Dave? Dave Doyle? David? Dave or David? And I guess it's technically morning. I'm still going to look at it as if it's the night, though. It's a late night. We're going to call it a late night. But I guess it's a matter of perspective. Yeah, okay, cool. My cousin's name is David. Sometimes I call him Dave. Are you up early or are you up late? Oh, 8:36 a.m. for me. Yeah, cool. 8:36 a.m. Where is that? That's, are you in the UK? No. Yeah, are you in the UK? SVD works with LCM. Yeah, I haven't tried LCM too much. Yeah, UK, cool, man. Cool beans. We're just over here trying to make a video out of Flux. Or make Flux make a video. However you want to say that. Northern Ireland, cool, man. Yeah, this is the furthest we've gotten with it so far. Yeah, we tried running the whole batch of 24 frames through Flux last time, and it clogged up my VRAM. So now we're going frame by frame. It should be about done. I just don't remember if I had the code right at the end to stitch all the frames together, but it's processing the frames, so that's progress for sure. But this gives you an idea of like what to expect in terms of how long it's going to take to process everything. Yeah, the consistency is not dependent on Flux. All Flux is doing is touching up the frames. The consistency of like the subject's movement in the frames is all on SVD. So that's entirely up to SVD. It has nothing to do with Flux. Flux is just to really process the frames and make them look better. But the content of what's in the frame, that's SVD. Yeah, exactly. Flux AI video, yep. Flux is hot and video generation is hot, so together should do pretty well. I kind of have a good niche going with the comfy stuff, because I have like such a heavy software background that I'm able to like get in here and make these things, customize these things. So it's kind of I feel like I found my calling. Gotta be getting close here. How many have we done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. If I'm counting right, that should be 22, and then this should be 23. So we might have one more after this, unless I miscounted. And also our denoise is at 0.88, which might be it might be too high on the denoise. So if the denoise is too high, then Flux might change the frames too much, and we might lose. Like I said, the content of what's in the frame is up to SVD, and usually it can do an okay job. So we want to make sure we use Flux to touch up the we want to make sure we use Flux to touch up the images, but not so much that we change the content of the image. So it's going to be a matter of balancing that denoise value. Okay, so we got Torch Cat expected a non-empty list. Yep, that's because I wasn't appending them to the list, I bet. I'm pretty sure I remember that, and I didn't change it before I started the run. Yeah, so we're using Flux right here, but then we're not sticking it into the stupid list like we were supposed to. So, yep, that was totally my bad. Alright, so we get that there, and then we'll just say seek flux latents dot append seek flux latent, and then seek flux images dot append seek flux image. Alright, so that'll put them in the list, and then Torch will cat them together at the end. And yep, so close. Torch cat, seek flux, latents. Let's make sure this is good so we don't have to sit through that again for nothing. Right, that should be good. And then so we cat them together, and so that'll be a tensor at the end. And right, because each of these tensors is 1 by 16 by 128 by 128, so that's good. And then at the end we should be good there. We got the images, that should be good, hopefully. SVD, seek SVD images. And let me just make sure real quick on the seek SVD images right here, and then we do the unsqueeze so we get our dimension back, so that's good. And then the VAE encoded is the right shape. Yeah, okay. So now we're actually putting them into the lists. That's good. And then at the end we can cat them together, and then we stick that up to the main list up here, the sequence latents and sequence images. And then we cat that, which we're only doing one sequence, so there's not really any catting going on there, but whatever. I guess I might as well just go ahead and put dim 0. I don't think it really matters, but we'll just do it. We'll just do it. Okay, I don't need that. Thank you, though. And yeah. And then the rest of this should be as it was already. Alright, I think that should work. Yes, I know. I know. FlowState Radio. Alright. So about 20 seconds per frame and about 24 frames. You know what we could do, actually, now that I think about it? Let's speed this up. For one thing, let's just go 24 steps on the SVD, and let's go with, like, say, 12 frames instead of 24, and that'll make things faster. And multipliers 4, that should be fine. Alright, let's give that a shot. Haven't gotten around to trying your nodes workflows, but loving your super neat workflow approach, giving me inspiration for my own workflows and node groupings. Yeah, it's like I've been talking with some people about it. I don't want it to necessarily be like Forge, where it's all just kind of like one big form. I like the kind of flow with the noodles, the pipelines going from one node to another. It lets you see exactly kind of what's going on in the process, which I like better than the like Forge interface, which is just like a form where you just select some options and then it does whatever it does. So I like this format, the comfy format, but I also don't want it to have like tons of nodes everywhere, so I think this is a good balance. Sunday. Thanks. That's what I'm shooting for. Logical. Alright, so here goes SVD. We're doing 12 frames this time instead of 24, so pretty fast. And we're only going for 24 steps? Yeah, instead of 32, so that's a good bit faster. And then we only got 12 frames to get through on the Flux side of things. So shouldn't be too bad. 12 times 20. Call it 100 and maybe 2 minutes or less. Right? Am I doing that math right? Roughly 20 seconds, roughly 12. Well, not roughly. 12 frames, roughly 20 seconds. Yeah, that should be under 2 minutes, right? Okay. Yep, here we go. Number 1. Seconds. Yeah, we can also for one, we can go fewer steps on these Flux steps. It does not need to be 32 steps. We could go for 20 and it would be just fine. And we probably need to turn the denoise down. I forgot to do that. But it should produce something interesting. Number 4. Okay, number 5. The anticipation, yep. Need some like cinematic music, cinematic rising action ambient music. Haven't tried SVD yet, only got a 3060. 3060 will probably handle SVD. SVD is not too huge of a model. My right now I'm running Flux, but my VRAM's sitting at 69%. So, and that's Flux, so but it's pretty similar for SVD, so it's not too bad. Yeah, we all need big GPUs. Yeah, there's also like cloud solutions too. If you want to, if you really want to try that stuff out, you can just spin up like a little remote server for a few, an hour or two, and do what you need to do, and then shut it down. I think there's a platform called like Think Diffusion or something like that. Think Diffusion. Yeah, I'm pretty sure this is it. Stable diffusion in the cloud. Yeah. So I don't know their pricing. Looks like they have like a free trial thing. But yeah, same thing. You can use Comfy in there. I haven't tried it out, but I've seen some people messing around with it. Run Diffusion, I think it makes you pay at least $10. Yeah, $10 will probably get you pretty far though. Think Diffusion, awful pricing. Okay, good to know. Good to know. It would be great if we could just like get a group of people together and chip in to build like a big cluster, and then everybody who chipped in on it gets remote access. That would be super cool. I'll build it if we can figure out a way to pay for it. Nice. Okay, let's see here. Ah, very interesting. The quality is definitely much better. So this is what's going on here is SVD just did not do much with the movement. So we got to tweak the SVD settings, and yeah, we got to tweak the SVD settings a little bit to make sure we get the right motion in the frames, and make sure we'll tweak our denoise. The denoise actually looks not bad. It's hard to tell because I don't know what what I should do with this node, at least while we're testing, is have it output the original SVD frames and output the Flux frames as well, so that way we can see what the motion is in the SVD frames. But what I would guess is, because just after messing around with SVD for so long, is that Flux probably didn't change the motion too much. This motion that's going on here is probably what SVD generated, and then Flux just touched up the frames. So I would say our denoise in this situation is probably not bad. It could be a little bit lower, but really what we need to do is work on the SVD part and get get SVD to produce something that has more motion. So we can do this real quick. Let's say if we go 24 steps is still fine. Guidance, I think we're going to turn the guidance up to like 8. And then the min CFG, we're going to bump that up to 4. And oil or de-dim, denoise is fine. And then we're going to go with the motion bucket. We're going to crank that way up. Let's say like, let's crank it up to like 444. How about that? And see what that does. Yeah, it works. It do be working. Yep, proof of concept is the goal. And then from there, once we have, well, we got the proof of concept now, and from here, now we just need to tweak it and SVD models quantized. You know, I don't know. Probably, I would say probably. I think most models are quantized, because if you try to run the full model, it would probably be not doable on consumer grade hardware. That's my guess. That would be my guess. All right. Frame number 1. And what do we have our video combine settings on here? Okay. Yeah, that looks fine. Okay. Cool, man. The quality is definitely Flux quality on the frames. Much better than just SVD by itself already. So that's cool. Cheers, man. Cool. I didn't even think we would get to this end part before I wanted to go get food, but I'm glad that we got through this at least. That's cool. Yeah, the frames individually are definitely much better quality than the frames of SVD. So we got a proof of concept. Yeah, we definitely need, we got to tweak the SVD settings and make sure we get the right amount of movement. And again, that goes back to the image as well, because SVD really needs a pretty specific type of image to start with, because a lot of images, I think I was saying earlier, a lot of images, SVD just kind of wants to do a zoom or a pan or a rotate kind of shot. Getting it to actually make her legs move is a challenge for SVD. You have to really dial it in with each image. Because the easiest movement to do is just like a zoom in or a pan or a rotation or something like that. So that's what SVD tends to try to do. One, 2, 3, 4, 5, 6, 7. All right, so this should be number 8. Cool, man. It's a proof of concept. That's pretty nice. And it's running, you know, it's 67% on the VRAM. It's not bad. Exactly. Yep. That's the truth. Really what we need is a better, on the SVD side of things, to actually produce the frames that include the movement. I mean, it's not yeah, I mean, I guess you could say it's kind of hard to work with. It's not, I wouldn't say it's really hard to work with. It's just, you kind of have to know what its little, you know, what its little, what its preferences are. But it's not really hard. There's maybe a little bit of a learning curve when you first start, but it's not, once you figure it out, it's not too bad. But it's definitely not like a one and done, like set it and forget it kind of thing. Like, you can't dial it in once and then have it work the same for every image. Like, the way that it produces motion in the frames is going to be very much dependent on the image. So for each type of image that you want to generate a video from, you're going to have to kind of figure out what the right settings are going to be in terms of how much motion and how many steps to take and frames per second and all that stuff. For the most part, the sampling and scheduling algorithms are, you know, not going to change that much from image to image. Just kind of depends on if you want something more animated and cartoony, or do you want something more realistic. Huh. Very interesting. Well, I expected there to be more motion. I guess there's maybe more overall motion in the image, just not with her. Huh. Very interesting. We turned the guidance up too high, probably. I hate to... okay, let's just try it one more time. Let's just try it one more time. And while we're at it, we'll go into here and we will turn the steps down a little. We'll turn the denoise down a little too. Let's go with like 68. No. Yeah, let's just try 68. And then our steps are right there. And those go in right here. Let's just, instead of 32, let's turn that to 20. And yeah, let's go with that. That should be a good bit faster. Yeah, my server's offline. Yeah, that's the thing with SVD. You gotta kind of... I turned my guidance up too high, so it was... The guidance and the CFG is gonna make it... Because you have the input image coming in, right? The picture of her just kind of standing there. And if the guidance is up too high, then SVD is not going to want to stray too much from that original input image. So I turned my motion up pretty high, but I also had the guidance too high, so no big deal. We'll try it one more time. And then I'm getting some food for real. For real, for real. Yeah. So we want to keep the guidance down a little bit. Usually around 4 or so is good. 3 or 4 on the guidance. It just depends on if you're getting too much motion on the image, then you can turn the guidance up a little bit, and you could try turning the motion bucket down a little bit. If you're not getting enough, obviously you want to turn the guidance down some. But basically it was trying to do as much motion as it could while still sticking to the input image as closely as possible, which is why pretty much you just get a bunch of shading and stuff changing around. Okay, 12 frames. Here we go. Here we go. All that icing and all that cake couldn't make it to your funeral. Surely be at your wake as my... Okay. I'm gonna head out after this one. Yep, me too, man. Me too. But I'm happy we got through this proof of concept stage. That's the hardest part. Yeah, tomorrow we pop off, for sure. Tomorrow we can build on this progress and we can tweak it and fine tune it, and we'll get some really solid results by the end of our stream tomorrow, for sure. Alright, sit down. I know. We're going soon. Last one, I promise. Sit. He's gotta go poo. I know you gotta go poo. One, 2, 3. Alright, you need to chill. Sit down. We'll go in a minute. Just hold on. 4 a.m. for me. Yep. It's a late one. I mean, my sleep is all over the place, so it doesn't really matter when I wake up or when I go to sleep. I just want to try to stay on a schedule that accommodates my YouTube audience, so that way I can stream around the same times you guys are available. Lay down. Yeah, tomorrow's going to be great. We will clean this thing up and make it produce some solid results by the end of the stream tomorrow. I'm going to get some food and hit my little skinny little J here and take the pup out to poop. Get a few hours of sleep and wake up and get right back to it. Might have to watch something. I might check out that penguin show while I eat. I haven't been on Plex in forever, man. I can't wait for Severance, man. It's been such a long wait. Yeah, take care, man. We'll see you next time. Yep, episode 5 drops tomorrow, or today rather, yeah, of Penguin, yeah. Cool. Oh, the other thing too is Dune. Dune made a show, or I don't know if Dune made a show, but I think it's like HBO or Showmax or something made a Dune series. It looks like kind of gay. It's definitely not going to be as good as the movies. It's all about the like sisterhood or whatever, but still looks all right. Interesting. It's like somebody trying to walk into the frame here and then morphing into something. All right, that's a good stopping point, I think. Call it a night there. We'll pick a different image tomorrow, see if we can get some more movement, and tweak the... Is it good? Yeah, it looked, I don't know, like I like the movies, but the show looked kind of... I'm always skeptical of shows whenever there's sex in the trailer. It's like, does everything need to be sexualized? But whatever. I'm sure it'll be good. Yeah, settings stream. We'll be tweaking the SVD settings, tweaking the Flux settings, just kind of dialing everything in. Definitely by the end of the stream, we'll get some really solid results. So I think that's good progress, a good stopping point. All right, y'all. Thanks for sticking around. I am going to hop off and get some food and all that good stuff. And I will see you guys tomorrow if you're here. Have a good night, y'all. Take care.